Всем привет! Всем привет! Продолжаем. Что тут у нас? Какой сегодня день? Какой чудесный день. Да? C++, C++, C++ у нас был очень давно. Мы сделали gate node, сделали и do once node. Да, давайте посмотрим на них. Здесь его делали, да? Такой вот gate node, типа, но не совсем. Так, давайте смотреть, что мы там делали. Вспомним, что мы делали, и будем сегодня смотреть нового мужчину. Посмотрим, что он нам там расскажет. Вот, чему он нас научит. У него там 18 видео, по-моему. Вот, ссылку на него, на этот, как называется этот плейлист. Вот, или как там он называется, действительно. В общем, плейлист, да, оставлю в описании потом. Вот, кто захочет, может пересмотреть, переслушать его или вперед побежать. Так, а теперь мы смотрим, что мы сделали. Мы создали, значит, пустой наш класс и прописали в нем, значит, подключили gate generated.h, ее struct, blueprint type, что это, структуру обозначили, generated body, public, force line, f-gate, explicit force line, туда-сюда. Force line это, по-моему, мы прописали для того, что если у нас нету гейта cpp файла, да, но он у нас есть, поэтому так вот. Так, мы прописываем, значит, наши функции о том, что вот эта вот переменная begate open, значит, когда мы вызываем open, она true, значит, когда мы вызываем close, то у нас begate open false. Toggle туда-сюда гоняет его, то есть разворачивает значение. Bool is open у нас return b, begate open. То мы объявили эту нашу булевую. Force line of gate open false. Я не помню, что это, но я помню, что мы такое уже делали. Так. Потом мы это все в нашем виджете, да, вызываем. То есть мы присоединили к нашим кнопкам на event onClicked add dynamic. Здесь вот в этом виджете используем uText widget on execute. Это где uText widget? Да, это наш этот, ссылка на него, и в нем мы используем on execute click. Вот он. Нет, execute click, вот он. То есть в котором, если у нас gate is open у нас возвращает значение всего лишь. Если true, то +1, если false, то ничего не происходит. На клик мы close делаем, open, toggle понятно. В принципе, все. Изначально аккаунт равен единице, точнее нулю, и текст label устанавливаем со значением count. Вот, после, да. Ну, естественно, все подключаем. Это то, что мы сделали. Do once я не помню. Мы этого не делали. Но принцип точно такой же. То есть мы создаем пустой этот самый, создаем в нем функции, которые будут выполнять то, что мы захотим, и после первого раза они уже не будут выполнять. Хотя вот я не понимаю, почему вообще для do once делать... ну да, мы же определили, что так проще читать будет. Вот, а так постоянно переменную создавать. Вот, окей. Окей, будем считать, быстренько пробежались. Уже все забылось. Все забылось. Но вроде бы нормально. Вроде бы нормально. Так, давайте я открою видос, который мы сейчас будем смотреть. И мы будем его смотреть. Так вот делаю. И вот так вот вам делаю. Давайте узнаем.
Let's talk about using C++ for Unreal. If you're here, that means you probably are either here from a background in an engine like Unity, or you've already watched my Unreal Basics tutorial series, in which we do work with blueprints. If you haven't watched that, go skim through it and see if there's anything interesting in there that you want to see first, because I'm going to skip over a lot of those things here. Let's start by setting up a project now. I'm using Unreal 5.1.1 for this, but most of this should be transferable to both Unreal 5, even some versions of Unreal 4 probably, and up to 5.3 and probably beyond for quite a while. So in this series we're going to make something a little bit like a twin stick shooter, and none of this really works too well for that as a template, I would say. So we're going to have to recode quite a bit. But I do think the top-down template probably is the closest to what we're going to be using. So I'm going to use that as a template so we have a starting point and we don't need to start actually from scratch. And the project defaults we're going to set to C++, because we're going to be writing C++ code. Everything else doesn't matter that much. I'm going to call this CPP tutorial basics, and we're going to create the project, which will take a little moment. While that is setting up, I want to show you the IDE that I'm using. That's Visual Studio Code. I will leave a link down below in the description to where you can download it, because I'm actually using this Unreal Engine 4 snippets plugin.
Я пробовал делать
Unreal 4
и по гайдам его, и по этим,
and that allows you to
по
make
поводу...
a lot.
Так, не бубни вместе со мной. По поводу Visual Studio Code, по его гайдам, да и по остальным, нифига вообще не получилось. Ругается прям ужасно. Вот. Вот, в принципе, все, что я хотел сказать.
Easier. Having all these macros that would usually be kind of bothersome to work with. Oh, apparently it also has a set timer one. I have never used that one, but that's good to know. So in Visual Studio, go to your extensions and look for Unreal Engine 4 snippets and just install that to your IDE. And just as I finish explaining that, the project starts up. So let's go into the editor preference real quick, because we want to make sure if we type in source code editor that it's set to Visual Studio Code. If you have any other IDEs installed like Visual Studio or, I don't know, C-Line, don't even know when I would have installed that, you want to set this to Visual Studio Code, because that's usually what I like to use because of that plugin. And now we can see we have a project file like we used to, but we have a folder with C++ classes. And if we open that up, and we can see we have a player controller and a game mode and a character. So let's open up that character. And when that opens up, you might get a pop-up like this. And you just say, yes, I trust the authors. And that opens up our first couple of files, which we'll talk a little bit more about how these files are structured and what they're doing in the upcoming parts. For now though, you want to make sure that everything here doesn't give any errors or anything, and if there is any errors that you don't really know what to do with, if you haven't done anything as far as adding any code yet, it's most likely because you need to build your Visual Studio project file. So you can just right-click on the U project file here in the left-hand side. If you don't have this Explorer, it's this icon up here that will collapse it. And we can reveal that in our Explorer. If you right-click on that in your Windows Explorer, you can generate Visual Studio project files. And that will just regenerate any missing project files for Visual Studio. So if you've just added a new C++ class, sometimes you do need to do that. It should do it automatically, but for me...
это, кстати, то, что мы делали, да? То есть то, что перезапускать постоянно надо было. Можно вот эту штуку сделать, да?
We're just setting up the project and going over some of the most basic features, one of which is going to be live coding. Because unlike what you might be used to in Blueprint, where you are inside the engine, inside the editor, making all of your code, we're writing our code in a separate program. So anytime we want to apply the changes we have made, we need to rebuild the engine. And that is a very lengthy process because that would require us to close down the engine, build, and then reopen. And that would be very, very annoying. So luckily, there is something called live coding. Going back into the engine here, if we go into the project settings, we can look into...
Вот он здесь, он по поводу лайв-кодинга говорит, что вот он будет им пользоваться. Вот. Но на прошлом стриме нам сказали, что иногда он ломает весь проект, и все идет по одному месту, и приходится откатываться. А это нехорошо.
And don't worry too much about what I'm doing here. We'll talk about that in a later video. But I'll mark it as a UPROPERTY that is visible anywhere. In order for this test flow to be visible for us in engine, we need to now use live coding. So if we go back into the engine here, we can see this little icon, which you can't see actually. So let me... This little icon in the bottom right. It recompiles and reloads the C++ code for your game on the fly. So if I press this, it will start recompiling everything, and I misspelled visible anywhere. So let's try it again, now that I have that fixed. And it will recompile the changes you have made, and after it's done all that, which will take a minute, especially the first time, it will take a minute because it needs to compile a lot of stuff. After this, it will only recompile the changes that you have made. And now if we go into our top-down, our blueprint that is based on that C++ class that we've just edited, we'll be able to see somewhere in here, let's open the full blueprint editor real quick, we have a test float which is visible. It's only visible, we can't edit it because I marked it as visible anywhere. Again, we'll do a separate video specifically on UPROPERTIES because it's something that I really, really need you to understand, but not for right now. Another way to do that is going back into your code editor here, your IDE. Let's copy this over and say we want test float 2 as well. A shortcut that you can do while inside Visual Studio Code, so you don't have to go back to Unreal and press that little button that's very hard to hit sometimes, especially on a bigger resolution screen. You can also press Ctrl-Alt-F11, and that is a shortcut that will recompile and live code everything as well. And now we'll be able to see we have test float and test float 2. You'll also know, by the way, this is very useful, because I'm using this specific capitalization technique where we capitalize the first letter of every word in the variable, it automatically puts in spaces for us there. So that makes things just a little bit more readable, which is quite nice. Now, let's close the engine and restart it, and you will see there's a little bit of an issue there. Now that I have restarted the engine...
Типа да, это прикол лайв-кодинга в том, что после перезапуска нифига нету уже. То есть все изменения не применяются на самом деле. For lack of a better term, patches in the new additions that you've made into your current session. So it's not actually recompiling the engine as a whole. And there's two ways to go about fixing that. Number one is, I think, in the editor preferences. Maybe this one is in the project preferences. We will see. In your editor preferences, you can tick the force compilation at startup, which will force the source code to compile into your engine. То есть это принудительно, да, компилирует в момент старта. А это разве не проблема будет?
Project, you will have the latest version of whatever code you have written, because it will always compile. That said, if you have a error in your source code,
ну да, вот.
So let's say
типа ошибка какая-нибудь, до свидания, он у тебя ничего не сделает.
Instead of a float, that's not going to compile, because this is a data type that does not exist. And if you want to compile the engine every time you start up a project, because of this error, the engine itself is just not going to start. So while it is very useful to compile the engine upon startup every single time, it's also quite tricky because it might lead to you not be able to open your project in the first place. Of course, you can still access all this code because it's in separate files, but maybe you don't want to bother with coding, you just want to play around with code.
Это какая-то
That's tough luck because you need to fix your compilers before you do that if you enable adoption. So I personally don't like turning this on, but it is there if you think you are brave enough to deal with that. The other solution is coming up here, and let's just put that back. Turning the engine back off again. This is very important. You can't compile and build the engine while it's running, so you need to close it down. And then with Ctrl, Shift, and B, we get a build. So we can build our game and our engine. And we'll look for our project name, editor, Win64 development build. That is the one you want to build. So if you just press that, it will start building the whole engine. And now after this,
вот я когда запускал эту штуку, она только один раз у меня сработала, потом она у меня вообще не работала, эта штука. Вот то, что он сейчас делает. Он ее показывал в другом, по-моему, гайде, эту штуку делал, но она не работала.
There's no live coding enabled at all.
Последующих раз.
So let's see if I look for our test float. They both exist anyway because we've built the entire engine. So those are some of the more basic things that you need to know about just how the IDE and the engine interact with each other. We're not going to go into any actual coding today. Next time we will talk about making classes and how and when to use C++ and how and when to use blueprints, because both of them are going to come together to make a very smooth and nice development process for us all.
Окей. Окей. Такой вступительный ролик, так сказать, был. Давайте дальше. Дальше вот он будет уже нам полноценно показывать, рассказывать, что, куда и как. Сейчас я тут настрою, у меня тут, как обычно, все так. Смотрим.
Let's talk a little bit about classes and how we're going to structure things to make them make sense. Because what we're making here as an example project is a simple twin-stick shooter, and I just downloaded this free asset with this character so that we can have something a little bit more appealing to look at than the default mannequin. And in the end, what we're going to need is we're going to need one class for just magic character, which will inherit from the normal character class. And then from that class, we're going to split off our player character and our enemy character, which those two will have slightly different things that they need to be able to do. But they both share quite a lot of things, like being able to carry a weapon and being able to shoot with that weapon. Or maybe the weapon itself will have the shooting functionality. We'll see about that in a moment. But let's actually get just started with making that first class, shall we? So we can go into our C++ classes and we can make a new C++ class. We're going to be a child of the character because we want everything that the character has, and we're going to add things on top of that. Then we want to choose whether or not we want a private or a public class. Usually we just go with a public class because we want to be able to access things, and we'll call this base character. Let's call it base magic character. And then we will create that class, which will create a new header file and C++ file. We'll remove the tutorial character that we've made before. And if you've seen my last video, you will note that, hey, we have some errors here already. I haven't even done anything. How does that happen? Well, if you've seen the last video, you know the answer to that is we're going to open the file explorer for our U project, and we simply need to generate Visual Studio project files. It's very annoying. I do believe that this is probably maybe something that's just wrong on my end.
То есть он ругается из-за того, что он как бы создал его, но он как бы не видит его еще.
If you have the same problem, at least now you know how to fix it. Okay, let's talk about header files and C++.
Еще раз, ну подожди, стоять. Стой. Еще раз, что именно ты нажимаешь-то?
The file explorer for our U project, and we simply need to
generate Visual Studio project files.
Visual Studio project. And it's a 5-minute fix to take forever. Okay, let's talk about header files and C++ files, because you might not be used to working with that. This header file is where the actual class lives. This is where we declare everything. So you can see we have a function here with the same name as our class. This will be the constructor. We have a function here for begin play. We have a function for tick, and we have a function for setup player input component. We don't actually really need that, but we're going to keep it because why not? But you might notice that these are only a couple of lines and there's no actual code here. And that is because our CPP file is where the actual code is getting implemented. So this will include that header file, and that's just more or less saying that, hey, everything that's in this header file, act as if that's just copy-pasted on the very top of this CPP file. So we have access to everything that's in this header file, that mainly being the actual class that we have here. So we have the class name, a base magic character. You'll notice that I didn't add that a myself. That's something that the engine did for us, and that is because of the standard naming conventions that the engine uses. Anytime you're making anything that's an actor, and a character is a pawn, is an actor, it's going to add a in front of it, just so that you can at a glance see, oh, this is an actor, and this is something.
Это понятно, это еще от того, мы знаем.
A base magic character. Then we have this double colon, which is, if you're used to C#, in C# you have the dot operator, right? If you have a variable, let's just very quickly make a f vector, which is what a vector is called. You'll note that this doesn't have an a in front of it because it's not a actor. I don't actually know what the f stands for, if I'm being frank with you. You might be used to using the dot operator to get something out of a variable or whatever. Well, if you're using a static class like this is, in C++, you're using a double colon. So what we're seeing here is more or less just we have this class, and inside this class we have this method, and that is what we're implementing here. So for the constructor, everything that it's doing so far is just setting the canEverTick, which just really enables or...
То есть я правильно понял, вот эти вот двойные двоеточия, будем так, да я не знаю, или четырехточие, это типа то же самое, что вот как через точку мы обращаемся к классу, только вот к статик этому, или как он это называл. Короче, то же самое, только для более крупного, что ли, я не знаю, как объяснить. Вот. Это из того, что я понял. Не факт, что правильно.
And then the same thing we have here, we implement the begin play, which runs when a character is spawned in or when the game starts. Tick is just your update loop. This will run every frame. We have a delta time in it as well. And then we have a setup player
это понятно, это мы знаем. Дальше.
As well, which sets up the player input component, which we don't really need for this character because it's going to hold all the general code that needs to be shared between the player version and the AI controlled version. But it just adds this by default, so that'll be fine. One more thing that you will note, though, is that all of these other functions, begin, play, and tick, have a super tick, which sounds very impressive.
Да, вот что это такое?
Interesting, but all that this is doing is it's saying whatever is in this function in the parent class of this class.
Мы поняли, что это. Точно, я вспомнил. Мы же тестили, то есть супер это вот, это именно вот этот вот блюпринтовый, блюпринтовый вариант, то есть все, что до него, это до блюпринта выполнится, а все, что после него, это уже после блюпринта выполнится. То есть это, грубо говоря, наш блюпринт. Вот. Ну, то есть, получается, если begin play вот этот идет, то если смотреть так, то вот тут вот это то, что до него выполнено, блин, как будет видно мое? Не, стой, вот... Подожди, вернись обратно. Вот, begin play идет. То есть, вот до него то, что будет выполнено, это до вот этого вот. А после, это вот уже после всего блюпринта, то есть, после вот этого вот, что уже сюда будет выполнено. Вот такая вот история. А там давайте посмотрим, послушаем человека.
In the parent class of this class also run that. So we have this base magic character, which inherits from the public class character. And if we hover over that and we press F12, we go into the header file for character. And then we can go step and we press F12, character, which inherits from the public class character. And if we hover over that and we press F12, we go into the header file for character. And then we can go a step deeper into a pawn, and then we can go into a actor. And somewhere in here, there is the first instance of the tick function. I think it might be on a actor. So let's see if it is anywhere in here. That's way too much to look through. So I'm not going to look through it, but just believe me, somewhere in here is a tick function that our character is doing this super thing. This will make a little bit more sense in a minute when we implement our own functions and we don't need to go digging through the literal thousands of lines of code that the engine has already written for us.
Нифига не понял.
Very confusing. So let's make a function for ourselves, right? Because what we need is we need a function to shoot. I'm not actually sure how we're going to do the implementation of it yet, but let's just make that function. We have three sections here, public, protected, and another public. This is just the availability of whatever is under that section until you put another one of these keywords down. So we have public, which is accessible to any other class that has a reference to an object of this type. We have the very well-known private, which is not in here, but I added it myself now, which is nobody can access anything about this other than this class itself. Then we have protected, which is kind of a middle ground between the two. Other classes can't access whatever is in protected. So it's kind of like private. Except if you make a child class of base magic character, which we're going to do eventually, we're going to make player and enemy classes out of this. Anything we put into the protected section will be able to easily be accessed by the children of this class. Where anything that we put in private, not even the children of this class will be able to access it at all. So we're going to put this function that we're going to make in the protected section. I'll just make a void shoot function, and I don't really think we particularly need any parameters for that. And the easiest way to implement that is just to right click on it and create declaration/definition. You can also make it in the CPP file, and then it will add the declaration in the H file. It works both ways around. It might take a little minute to actually do that though. And now we have a method that we can actually start putting code into in our CPP file. So whatever do we want to do when we are shooting something? Well, when we're shooting something, I think what we want to do is we just want to call a method on a weapon. I think having the weapon itself worry about
Дофига всего должны вызвать на эту
makes the
функцию.
most sense to me. So let's make that class as well. We've already made a class, so pause the video now and try to make the weapon class and also a bullet class all by yourself, and try to create a function on the weapon class that is also just called.
Вот это ты прикольный чувак. Вот это вообще прикольно. Говорит, давайте напишем механику стрельбы, окей, да? Я вам сейчас все буду объяснять. То есть ты только что объяснял людям, что такое обычный актор. А тут ты говоришь такой, мол, типа, не, ну вы как бы класс оружия создайте, все для него, и класс пули создайте, все для него, типа, сами. Ты прикольный, прикольно, мне нравится.
Shoot. Okay, I'm assuming that you're done with that because we're going to be moving on. I will, however, just do them real quick for you. What we're going to do is the weapon will be an actor. I didn't specify that. I hoped that you would be able to figure that out on your own. If you didn't, no worries. And I'll call this base weapon. And then we'll also make another actor again, and we'll call this base bullets. Got to regenerate my project files because again, Visual Studio
Он будет показывать или нет, я чуть не понял.
And then in our base
Или сейчас
weapon
шлеп,
header file,
и
in
все
the
готово.
protected section, again, we're going to put a void. And this one I'll call weapon shoot, just to make sure that I understand when looking back at this, what is the difference between shoot and weapon shoot? Because otherwise you might get a situation where we simply run this function, which is called shoot, and in
Ну
that
да,
normal
назвал,
function
потом
called
будет
shoot,
сам
which is
путаться.
kind of
Ну, в принципе, как и я
so we'll
делаю.
call this weapon shoot to make sure that we actually properly understand what is going on. And for now, we're just going to leave this empty as well. We're going to implement some of the code itself in later parts. I just want to walk you through to the very basics right now of how to set up these header files and these CPP files and how to work with them and how they themselves function. And to complete all of that, what we're going to do is I'm going to go into this public folder here and go to my base magic character. And I'm going to right click on that and create a C++ class derived from base magic character. And we'll call this base player character. And I will make another one, and we will call that one base enemy character. There is a chance that we don't actually need a separate class for the enemy character, but I like just making them. If I
Подожди, то есть он создает parent класс от для enemy получается сейчас и для плеера, чтобы потом все вот это наследовать и вот этим всем пользоваться.
Adding anything into this C++ class that I particularly need for the enemy, I can always just turn things back and make the enemies just use the base magic class instead. But it's nice and easy to have this ready to be able to code in if there's anything that specifically only the enemy needs to be able to do. Now, we have the C++ class for our base magic character, which we then have a player character version of, and that we're going to make a blueprint class based on. So the very final step, the very final class we're actually going to be using in the game is going to be a blueprint class, because that will be open to us in the editor to change around values without needing to rebuild every single time we want to change a value, because that would be highly annoying. And we can also maybe, if you wanted to, add a little bit of extra blueprint scripting on top of that for things that might be particularly annoying or difficult in C++ to do. So let's create a blueprint class, and we will name this one player, and that creates a blueprint class as we know and love it. So we can open it up, and we will see just a normal character that we have. So let's put in the mesh component here, our wizard, and then we'll put that in the proper position and scale in a moment. For now, I'm just going to use a idle animation for the wizard because I don't have an animation blueprint for him yet. We'll make that at some point. I might make that off screen, to be honest. And I think we have some time for one last thing to do, and that is we're going to add a component through C++. I think that is something that really fits in with what we've talked about here today, and that's a nice last little thing before we end off this video. So let's close a lot of these classes that we're not using at the moment because I'm zoomed in way more than I'm used to, and it's kind of a mess up here in this taskbar. So let's open up our base magic character. In here, we can declare in the, I think the protected section would make the most sense, maybe private would work as well. What we're going to declare is we're going to declare a child actor component. And here we need to figure out what actually is that called. And that is where the Unreal documentation comes in. So looking through the documentation, you'll be able to find the child actor component. Because it's not an actor, it's a component. It might be called a child actor component, but it's because it's a component that holds a actor. It doesn't start with an A, it starts with a U. Components generally start with a U. And a lot of other things as well. So let's try to add that, right? We can add a child, if we type it out correctly, actor component. And we need to add a little star after it because it's going to be a pointer to that component. We'll talk about pointers maybe in the next video, maybe the video after. I'll explain them pretty soon because they are pretty important to understand. A very brief rundown is that this is a variable that's going to...
То есть, как мы уже делали, вот эту вот штуку он делает. То есть, добавляет... Блин, опять он бубнит вместе со мной. Вот где я пробел добавил. Пусть он там и остается. Это он добавляет, получается, компоненты к нашему character, ну в данном случае character. Вот таким вот образом. То есть он говорит, что это, и дает ему имя. А потом в CPP он будет его вот создавать таким вот образом, скорее всего. Давайте посмотреть.
Now we have a pointer to that, but how do we actually add this into our blueprint? Because just adding this isn't going to do too much. But we can make this, again, I'll talk about this in probably the next video. Make this a UPROPERTY so that we can actually see it in engine, and we mark this as added anywhere. Still, this won't really do anything because it's not initializing or not setting up any components. We need to do that in the constructor, and now this is throwing an error. Why? That's why. So let's go back into that CPP file that corresponds to that header file and say our weapon is equal to something. And now we're going to need to create the component. So the method for that is called create default sub-object, which is creating a default sub-object, a object within an object, so a component for our actor. And we need to give it within these angles.
Привет, смотрел я этого мужчину, не очень зашло, как он объясняет. Мне больше понравился другой курс от русскоязычного. Давай в студию ссылку. Вот. Будем смотреть. Да, и привет. Вот. Но пока мне... Я не знаю, я пока мнение не сложил еще, понравилось мне или нет. Но он странный, типа, мол, впиши в поисковик, я начинаю новый курс C++ в Unreal 5. Попробую, ну-ка. Так, да. Открыть тебя. Что с тобой делать? Нет. Так. Допустим. C++, принты в Unreal. Ага. А у него вот этот вот... Я, по-моему, на него даже подписан, нет? Плейлисты. Пум-пум-пум-пум-пум. Знакомый этот. А в плейлистах какой у него? Вот, создаем проект на C++ для Unreal 5, да, вот эта вот история. А что тут у него по видосам? Ой, 7 минут, 32 минуты, час, 30 минут. Ой, какая красота. Слушай, ну вот это красота. Это прям бомба. Это следующий мужчина на очереди, так сказать. Отходил, ну как, смотрел. Не, я этого не видел. Но этот мужчина на очереди. Я добавляю его. Смотреть позже. Во-первых. И он у меня в ссылках будет здесь висеть. В закладках. Вот, так что этого мужчину мы посмотрим. Но он на очереди, так сказать. Он следующий. Просто уже начали этого. Надо добить этого. У этого... Тут такие мелкие видосы. В принципе, я так понимаю, мы практиковаться особо там не будем. Но если что-то интересное выудим, вот, что-нибудь быстренько попрактикуем. А так, в принципе, ну, он так объясняет интересно, что, в принципе, просто послушать, посмотреть, и все. Ну, интересно, если что-то найдем, что можно будет применить, потыкаться, попробуем. А так... Ну, короче, в общем, сейчас досмотрим его. Хоть и начали только, но потом перейдем к этому. Окей, спасибо, полезная инфа. Так, продолжаем.
Angle brackets, the type that it's going to create, which is a U child.
Я все нафиг пропустил, подожди.
And that corresponds to that header file and error.
А мы здесь сделали weapon, это, да?
And now this is throwing an error.
И теперь...
That's why. So let's go back into that CPP file that corresponds to that header file and say our weapon is equal to something. And now we're going to need to create the component. So the method for that is called create default subobject, which is creating a default subobject, a object within an object, so a component for our actor. And we need to give it within these angle brackets the type that it's going to create, which is a U child actor component. And then in these parentheses, what we need is, we can actually see if we hover over this, there's 4 overloads for this. In these parentheses at the end, we need to put in the name of the component. So we can do that with the macro called text, and then in the parentheses after the text, we just type out the weapon. It's as simple as that, and then we end with a semicolon. This will add a child actor component to our base magic character. Now, we want to have this child actor component be parented to the mesh, because it's going to be in one of their hands. And if we just live code compile right now, we'll be able to see in a second. So now in engine, we can see we have a weapon, which is a child actor component in which we can put a child actor class. So let's make a blueprint class real quick for the weapon. So create weapon here, and we'll just call this BP default weapon. The weapon itself has nothing in it yet. We'll get to that in a moment. But now we can give this...
Подожди. Здорово, что ты его создал, ты молодец. Подожди. Сначала создал телефон, да? Что это за покемон? А это вообще покемон в покемоне, да, получается? Так что ли? А почему он именно так оружие создает? Или это так надо? Ну ладно, я спорить не буду, окей. Хорошо. Каждый день что-то новое. Так, смотрим дальше.
BP default weapon, which I misspelled, it looks like. And now this weapon just exists at 000 in this actor, which is not ideal what we want. What we want is we want to parent it to the mesh. But since we created it in C++, we can't just drag it onto the mesh. So we need to parent this to the mesh in C++, which is remarkably easy. Because after we create the default subobject, what we can do is we can say on our weapon, we use a little arrow because we're using a pointer. We use an arrow instead of a dot operator, like you might be used to in C# or Java or whatever. And then we can set up attachments. And what this does is this takes in another scene component and potentially a socket name. And the scene component that we're going to be attaching this to will be our mesh. And there's a function on the character itself that just returns a pointer to the mesh. So now if we live code this one step at a time and we recompile this as well, sometimes it's a little iffy with live coding. So what you can do, which I don't recommend you do too much, but if we just change this to like actor real quick and then we reparent it to base magic character, now we have lost our mesh. So it loses all of the information that you put into it. So again, it's not really something you want to do, but for right now, for just showing you, we can see that the weapon is actually parented to the mesh now.
Now I'm
going to actually Ctrl-Z my way back into this, and even now you can see that still works. So it's a little bit of an iffy way of doing it. Don't do that yourself because it does have the potential to break things. But even now we can't change the parent socket because again that's something we need to do through C++. So let's take a look at this mesh here. and take a look at the sockets. We have a socket called weapon sockets. So we'll copy that name over, and simply in our C++ code, the second parameter here will be, just as we did before, we do a text in all caps, and then we simply pass in the name of the sockets. And now, if we recompile that, I ended up having to rebuild and restart the entire engine for it to take effect, which with this kind of stuff does tend to happen. So if it doesn't work right away,
Отлично, у него все сломалось, и он переделывает. Молодец.
The weapon, it's inside of his hand because that is where the socket is located. So now I could put a mesh on this weapon class, and if it displays that mesh, it will just have the weapon in his hand. So that's a little bit of a challenge to you. Pause the video now and try to find out through the Unreal documentation, which you can just find through Google, what you need to do in order to add a mesh component. I'll give you one little hint. It is not going to start with an A. It's going to start with a U. And from there, it should be pretty self-explanatory what it is called. Try to figure out how to add that on your own. And if you can't figure it out, we're going to go through it step by step in a quite quick tempo after this. All right, let's go into the base weapon.h. And in the protected section, I'm going to add a U static mesh component, which we can see in the Unreal documentation right over here. So that is the component that we're going to be adding, and we'll call that weapon mesh. Then over in the corresponding CPP file, we're going to go into the constructor, which again is the method with the same name as the class itself, and we'll say weapon mesh is equals to, and I made a mistake because you don't want to make a U static mesh component. You want to make a U static mesh component pointer. So add a little star behind it. But just for shit and giggles, I'm going to show you what happens if you forget that, because this is something that you might worry about. When do I need to use pointers and when do I not need to use pointers, and what even are pointers? Again, we're going to get to what pointers are in the future. But for now, if you mess it up and you try to use a normal variable, you should be using a pointer, the engine is just going to call you out on it. So let's create default sub-object here of the type U static mesh component, and we'll call that one weapon mesh, as easily as that. Now, this time I'm going to need to go at the very end. There's going to be a little squiggly under this equal sign, and that is because we can't convert
Опять звездочку забыл поставить, да.
to a static mesh pointer. So if this happens and you're like, but everything about this seems right. Everything about what I've written here seems correct. What is the issue? The issue is most likely, and in this case, definitely, the fact that you forgot to make it a pointer. So when we make this a pointer, and we wait a second because VS Code can be very slow in updating this kind of thing, the error disappears, and now we have our static mesh here as well. So let's live code compile that. We can open up our default weapon, and when we look at that, we can see a static mesh component exists in here, and we can't edit it because I forgot to make it a edit anywhere U property. So let's just copy that over from here. Again, we're going to go into everything to do with U properties in probably the next video. But as we are going through this, I'm sure you can try to piece it together pretty well what it does and more or less how it works. But now that we have added that U property, we can actually edit the details here, and we can find the weapon for the wizard, which I'm not entirely sure actually what it's called. So let's add this one, which will then have added it to our character here. So now we have a character that has a custom component on it, or at least a component that we added through C++, which is an actor that has the component here that we added again through C++. So that's how you set up your classes and work with all that kind of stuff in C++. There was quite a lot here to be talking about, so do feel free to go back through this video a second time and just look at everything a little bit more closely now that you have the full context. Next time we're going to have a bit of a shorter video where I just highlight U properties for you.
Ну, здесь из того, что он делает, мы в принципе умеем. Это того мужчины мы еще научились. То есть создавать вот эти вот все компоненты и объявлять их и создавать, короче. Так, чем мне курс того дядьки понравился? Тем, что он там все в блюпринте переносил в C++, и удобно тем, кто уже хорошо знаком с блюпринтами. Слушай, ну ты мне прям расхвалил. Но это следующее, я же говорю. Мы сейчас, потому что, ну мы, короче, сейчас экстерном, скорее всего, по-быстренькому пройдем здесь. Я смотрю, у него небольшие видео, да, то есть за сегодняшний стрим вряд ли мы все это успеем, а вот за следующий точно, то есть. И получается, потом уже мы к этому дядьке перейдем и будем смотреть следующего мужчину. Но если ты говоришь, что там прям так, то это прям вообще бомба. Блин, но мне вот даже если он объясняет фигово, вот этот вот, который мы сейчас смотрим, И, в принципе, ничего не понятно и так далее, все равно вот будет какая-нибудь маленькая штучка, вот там хотя бы маленькая доля информации, которую вот запомнить, усвоить, и она потом полезная будет вот, по-любому. Поэтому нужно посмотреть. Вот, нужно этого посмотреть. А там посмотрим. Вот такая вот история. Так. Идем дальше.
Properties and functions, because that's something that you're going to need to use quite a lot. If you have some C++ code here, which we do, you can see I've added some things called properties to some of my variables. And if you're used to working in Unity, which some of you might be, this is kind of like adding serialized field to a variable. It just makes it available for you in the editor and in Blueprint. But it goes a little bit deeper than serialized field usually does, because you can see I can say this is a property, which will simply expose it to the reflection system, which makes C++ and Blueprint able to talk to each other. But then we actually have to specify a couple of properties to it. In this case, that would be edit anywhere, meaning that if I go into the engine, I can edit it in this Blueprint defaults. But I can also, if I pull this actor into the world, because it's set to edit anywhere, I can also edit it in the details panel here. If I go back to my property and I change it from edit anywhere to edit defaults only, and I recompile real quick, now you will note I can't actually edit the static mesh here anymore. But if I go back into the Blueprint itself, everything is still editable, because the property is now set to edit defaults only. Well, there's quite a lot of specifiers that we can use in order to specify what we want our property to be able to do. And there's an entire page about this on the Unreal documentation, which I implore you to read through. I'm not going to talk about all of them right now today. But maybe even more importantly than property is function. You could argue it might be as important, but we can make a function in much the same way, and that one we can assign as Blueprint callable. So we can call it in Blueprint. So we have our base weapon class here. If I compile that and I go into the event graph of our Blueprint version, and on begin play, for instance, I can now say weapon shoot. That's the function that we just made in C++ last time, is now accessible to us from Blueprint. And that is only because I made this function Blueprint callable. If I remove that, try as I might, weapon shoot doesn't exist in my options for Blueprint, because Blueprint has no idea that this exists. It doesn't need to know every single function on every single C++ file at all times, because you can make a lot of functions that a Blueprint user, like a end designer or whatever, is never actually going to use, and you don't want to just throw everything at them. So only when you want a script in Blueprint to be able to use a function is when you mark it as a property and you make it Blueprint callable. Now, let's say we have this weapon mesh here, but we also want to have something like a float, and we make that edit default only because we want to be able to edit it, and we call this the damage, right? Then we compile, and then we want to use that damage in something in Blueprint. Well, I'm going to just spoil that for you. That's not going to work. We have our damage value here, and we can edit because we set it to edit anywhere. But the moment we want to actually get our damage, like get damage, it doesn't exist in Blueprint because we haven't specified that we need to be able to read and or write to this variable in our Blueprint graph. We can only edit it.
Эту историю мы тоже все знаем.
So going back here, we can add more than
Blueprint
one specifier to a property. So we want to be able to add it in the defaults only, but we also want to be able to Blueprint read only. Now, in that Blueprint,
Здесь
will
для чтения
allow us
только.
to get our damage variable because we set it to read only. And as you'll be able to note,
Давайте посмотрим.
only. So if we want to try to set our damage, that doesn't exist. We can literally only ever get it. Which again, if you're a programmer working in C++ and you have some designers that are using Blueprint, and you're like, okay, you can read my damage value, but please keep your freaking hands off the actual value. I don't want you to change it. You can do that. You can just make it read only, and your designers will be entirely lost not being able to change it by hand. And of course, you can also make it both readable and writable by just making the Blueprint read-write. And now we can also set our damage, and all the designers are now very happy, and all the programmers have just gotten a heart attack. While we're at it, I'm going to also make a quick function here that is something like a float calculate damage, something like that, right? Let's just spell it out properly. And let's say that takes in a float for the damage and a float for the multiplier. This is a function that I'm actually not going to use. I'm just putting this in here for an example to show something. Because we can make this U function blueprint callable, that's all fine. But as you might have noticed, our weapon shoot, if we try to call that weapon shoot, that is one of these execute nodes. And that is fine, but what if we want to do something like get player character, one of these type of nodes, right? That doesn't need any execution pins, it just returns a value when it's plugged into something. This is called a blueprint pure node. And you can make those inside of Blueprint as well, of course. But the way you do that in C++ is just make it Blueprint pure. And it doesn't have an implementation, so that's not actually going to do anything. So let's just simply return damage multiplied by the multiplier. Again, just as an example. And we have a conflicting name here, so that is my bad. Let's just add an underscore there to fix that conflicting name. And now if we type calculate damage, we get a blueprint pure node where we can put in the damage and the multiplier, and it will return a float with the actual damage. It's a very simple case of doing this, in which case you might as well just use a multiply node, right? It's as easy as that. But you can make a lot more
экстерном, конечно, пошел прям мощно.
And just make it easily accessible to your blueprint designers. And again, go check out this page to just read through what all these property tags can do for you, because it is very good to be aware of these. But these ones that I've shown you so far are the ones I personally end up using the most. That is added defaults only, added anywhere. We have visible anywhere or visible in the defaults only. We have blueprint read write, blueprint read only. For functions, we have blueprint callable and blueprint pure. Those are the most used ones, and you're going to be using those 99% of the time when you're making something a U function or a U property. Those other ones also exist, and it's good to be aware of them, but I just wanted to show you what
Подожди. Подожди. У нас есть здесь вот паблики мы фигачили, да, делали, но мы-то объявляли входящие и выходящие параметры, да, а у него, получается, выходящий через float простое объявление идет. Выходящий параметр, да? То есть так тоже можно. И входящие параметры у него просто идут. Этот нам фигачил через const. Интересно. Ну вот это вот интересная история. То есть если есть один какой-то параметр, который выходит, ну по принципу, как мы делали там с булевой, да, по-моему. То есть вот у нас какая-нибудь математика с флотами происходит, да, там 10 флотов на входе и 1 на выходе. И вот 10 мы можем во входящих параметрах вписываем, там, да, функция, а этот это просто из-за того, что float написан, то есть uFunction, blueprint там callable, да, это для вызова, а общий как там? Опять что-то нажал.
Blueprint pure, and it doesn't have an image.
Callable, да?
Is or visible in the defaults only. We have blueprint read write, blueprint read only. For functions, we have blueprint callable and blueprint pure.
Подожди, но когда он callable сделал, прикол в том, что там не было у него этой ноды. То есть float, выхода не было float. Ладно.
those are the most used ones, and you're going to be using those 99% of the time when you're making something a U function or a U property. Those other ones also exist, and it's good to be aware of them, but I just wanted to show you what this U property and U function stuff is all about. So now that you're aware of that, next time we're going to talk a little bit more about pointer.
Окей, идем дальше. К старым таким.
Okay, I'm going to try to explain pointer variables to you, and you're going to have to stick with me because it's kind of a mess to explain. The best way to really get a feel for this is just to start coding and working with it, but it's good to have heard all of this information that I'm about to tell you before you actually get to that. So we have two types of variables in C++, which is a gross oversimplification, I am aware. But we have a normal variable, which is just a data type, like uStaticMesh that we have here, or a float, or whatever you want. And we have pointers, and pointers point to wherever the memory address is of another variable. So what we can do here is, if we have, I'm just going to use some f vectors as an example. We have a vector, and we'll call that the location. That's just the location in the world for this actor, just as an example. Then we can also make, if we really wanted to, which I also need to capitalize the V in vector, we can make an f vector pointer, which you just do by adding a little star after the data type here, and we'll call that a location pointer. Now, that location pointer is just a simple, very cheap variable that will not take up too much of your RAM. So if for any reason you need to reference this variable in a different location, you can make a pointer, and instead of having to copy over the entirety of everything to do with this f vector, or something that's a lot more heavy, like your entire player character, which might be entire megabytes of information, instead of having to copy over all of that data into a different place in memory, what we can just do is make a very simple variable here that will point to the place where this is stored in memory. That way we can access it directly rather than making a copy. Because if we try to, for instance, use this in a function, what it will do is it will make a copy of this variable, use that in the function, and then return yet another copy. So instead, if we make a function that takes in a pointer, it doesn't need to make a copy, it can just use the actual original data. And especially if you need to change something about this
Понятно,
data,
ну
if you
это,
have a
короче,
function that makes a copy of this
опять не то,
location,
что
then changes something and returns a copy.
То есть это как у нас есть, когда мы, допустим, какую-нибудь штуку вытаскиваем, не знаю, получится, нет? Массив тут есть, но это интеджеры тут не... Ага, вот есть. У нас здесь есть copy и reference. То есть copy — это создается копия, то есть мы работаем с ней. А reference — это прямая ссылка, то есть получается, если мы хотим работать с оригинальными данными... Так подожди, а с оригинальными данными, а где ты их потом присобачишь туда? Как этим пользоваться в C++? Ну хорошо, то есть это вот штука, когда мы получаем или копию, или ref. То есть если мы сделаем, вот здесь вытаскивали наш этот и захотим что-то поменять, то мы будем менять в этой копии, а не в самом массиве. То есть, а если мы хотим именно в массиве поменять, то нам нужно через reference вытаскивать, то есть вот этот ref делать. Это вот эта вот звездочка, о которой он говорит.
The original location vector isn't actually going to get changed. For that, you're going to need to actually point towards that specific place in memory. So, for example, let's just make a function increase vector, something like that. And that's going to take in a f vector, vector to increase. Let's create an implementation for that. So now, and I can't really show you this in here. I probably should have just made an empty C++ file. Well, that's a little too late now. We can still do that, maybe. Just believe me when I say that this works the way I'm telling you how it works. Okay, fine, good. Because if we now take our vector to increase, I'm just going to copy it over because I'm lazy, and we try to add to that a f vector of just 1, 1, 1, for instance, you might think, okay, we can pass in a vector here, and then it's going to add 1 to the x, the y, and the z for our vector. And no, that's not how that works at all. Because when you call this function somewhere else, like in begin play, like increase vector, and we had a member variable here just called location, that's not actually gonna do anything. Because what it's gonna do is it's going to call this function, it's going to use a copy of this, and increase that copy, and then by the end of this function, the function is done, so anything that was created in this function is going to get deleted, and nothing actually happened. You just wasted some computer resources with no outputs. Now, what we can do instead is, instead of passing in a location directly, we will pass in a vector.
То есть, да, опять нажимаю пробел. Слушай, надоел. В чем смысл? То есть, если у нас есть какая-то функция, которая делает какую-то математику, и если мы хотим, чтобы наша переменная, которую мы туда передадим, изменения какие-то произошли в ней. Ну да, тогда этот самый происходит. Ну да, то есть у нас есть входной параметр какой-то, и мы хотим изменить этот входной параметр. То есть не внутри функции, а после обработки функции, то есть после того, как функция выполнится, сделает свои какие-то вычисления, мы хотим, чтобы эти вычисления, результат этих вычислений применился к нашему входному параметру. Вот, изменил его. То тогда мы должны будем его объявлять через вот эту вот именно ссылку, то есть f-вектор ссылка. Окей, вот это полезно. Это опять какие-то, что ж такое?
Let's change this to a vector pointer, and now we need to pass in a pointer, which is a memory address. For that, we need to change a couple of things. First and foremost, we're not going to pass in the location, we're going to pass in the location pointer, and then we can't add a vector to a pointer, because the pointer is not a vector, obviously. So what you can do is you can put a star, much like you have a star at the end of your data type to make it a pointer. If you put one at the front of your variable name, that dereferences things and makes it go from a pointer back to treating it as if it's that variable. And now, this is actually taking in whatever...
То есть, окей, там, понятно, после надо ставить, а вот чтобы это все сработало, то есть он не будет плюсовать к ссылке, то есть ему нужно обратно вернуть ее на нормальное значение, типа, мол, если я все правильно понял. И поэтому вот этот поинтер ставится звездочка перед.
Vector we are pointing to and adding 1, 1, 1 to it because we're using a pointer. But how do we give this pointer a value? Because now we're declaring a location pointer variable, that's fine, but it doesn't have any value. And if you run this, it's actually going to crash your game because it's referencing a null pointer. And if it's a null pointer, meaning a pointer without any information in it, the engine or your computer in general does not like that. So we can give this a value by saying it's equal to the address of, which is this ampersand sign, this location variable. And you will see that works entirely fine. So we make a f-vector pointer and we say this pointer.
То есть если мы объявляем вот эту ссылку, то она пустая, потому что это ссылка, то есть в ней ничего не хранится. Вот. То есть если мы какой-то делаем f-вектор и объявляем его, то он будет по нулям. Если мы остальное что-то объявим, то у него будет стандартное значение есть, а у ссылки нет стандартного значения, будет пустая. Так как она будет пустая, короче, будет беда, быть беде. Вот, поэтому мы должны такую штуку сделать. Почему мы ставим вот эту штуку?
The engine or your computer in general does not like that. So we can give this a value by saying it's equal to the address of, which is this ampersand sign, this location variable. And you will see that works entirely fine. So we make a f-vector pointer and we say this pointer is equal to whatever memory location this variable is at. So in theory, for what we're doing here, we can entirely skip making this variable as well, because you can just do this in your code right away. So instead of passing in the location pointer, what we can do is we can just pass in the f-vector location, but we just pass in the address of location. And this will now pass through the pointer, which is the memory address of this variable, into this, and it will work perfectly fine. Hey.
Он сейчас объяснял такое, а можно сделать вот так вот попроще? Это что сейчас было? То есть вместо вот этого мы можем сразу,
making this variable as well, because you can just do
значит,
this in your code right away. So
в самой
instead of
функции
passing
во
in the
входящих параметрах
location
написать
pointer,
вот
what
этот
we can
вот,
do is we can just pass in the f vector location, but we
вот
just
эту вот
pass in the
штуку.
address of location, and this will now pass through.
Можно помедленнее, пожалуйста. Что именно? Видео? Помедленнее. Так мы офигеем его смотреть. Вроде бы так все понятно. Он, короче, или в последний момент, что происходит. То есть добавить вот эту штуку и... Да, видео. Да, окей. Мы, конечно, офигеем. В слоумо это смотреть. Ну да ладно. То есть мы, мы ставим эту штуку, а все остальное оставляем. То есть это будет то же самое. Спасибо, да, пожалуйста, обращайся.
The pointer, which is the memory address of this variable, into this, and it will work perfectly fine. Hey there, this is me in the middle of a variable into this.
Ну а дальше мы говорим, то есть в самом определении функции мы говорим, что это будет ссылка именно f-вектор, и потом ее, не знаю, как это, обратные ссылки превращаем в этот, делаем наши грязные дела, вот, и все, и таким образом он, значит, изменит. Прикольно.
And it will work perfectly fine. Hey there, this is me in the middle of editing this video, and I forgot to mention one relatively important thing. And that is, if you're used
Молодец,
to
что ты
any
забыл?
sort of programming, this is my own code for my own game that I'm scrolling through right now, you might see something that seems slightly weird to you. And that is, usually if you have a variable, so I'm just going to, again, make a f vector here, which we'll just call vector real quick. You use a dot operator to get anything that is stored inside of that data type, be it the x, y, z coordinates or any of the methods that you can find on it. But the difference being is if you are using a pointer, so if we make a pointer out of this and I use the dot operator, you will see it turns it into this little arrow instead. And that is because Visual Studio Code is nice enough to do that for me. Not every IDE will maybe do this, so it's still good to be aware of this. If you are working with a pointer variable, you don't use a dot to get something out of it, you use an arrow instead, which is just a dash and a greater than sign. Again, with Visual Studio Code, that will just automatically do that for you, and you don't have to worry about it, but it is something worth mentioning. So now let's get back to the video. Again, if this doesn't quite click for you, it doesn't for a lot of people. For some people, this is second nature and it just right away makes sense. If it doesn't quite click for you though, don't worry about it. A lot of people struggle with quite getting this at the start. So don't worry, now that you've heard all this information, as we go along and we do a little bit more coding and we do a little bit more experimenting with C++ code, it's going to start clicking into place at some point. As you're playing with it yourself, you're going to start realizing how this all works. And by and large, like I showed you in a previous video, when the engine expects a pointer, it will just scream at you when you're not giving it a pointer, and you just make a pointer out of it with the ways I've shown you in this video, and the other way around as well. If you're accidentally making a pointer and the engine is expecting something that is not a pointer, it will just scream at you and you can just dereference it in this way, for instance. So you will be fine. You're working in such a tightly constructed framework that Unreal is providing you. You can't really do anything catastrophically wrong with all of this memory mumbo jumbo. It'll be fine. Next time, let's actually dive into some proper.
Почему вроде умеет тест в прямом эфире? Ты про IDE, что умеет вот эту штуку делать после DOT? Давай. Где мы ее используем? Давай объявим какую-нибудь фигню. Допустим, мы тут, вот наш эффектор location. Мы прописываем наш location. Cation. Location, dat. И что у нас? Bound to box? Нет. А что надо нажать? Вот какую именно из этих он должен будет перейти? Down вектор. Давай, down вектор, допустим. Нет. Делает, он не умеет эту фигню делать. То есть... подожди, это ж мы не с вектором должны работать, правильно? Или с ним? Показать и создать. Не понял. Я не на том уровне, чтобы понимать такое.
Proper coding and mentioning. So you don't have.
Ты имеешь в виду... я понял. Все. Так, я понял, все. Мы убираем const, и мы вот здесь вот делаем pointer вот этот вот. И у нас все нафиг ломается. Но это ломается, потому что мы теперь умеем вот такую вот штуку делать, да? Или мы нифига не умеем? Создай эффектор temp. Ага. Давай сейчас const. Вернем здесь. Как было, создадим новый, не будем старый. Зачем я клацаю Enter? Это просто какая-то жесть. И у нас все сломалось. Все, пусть так и будет. Хорошо сломанное. Так. Сломанное это потому, что вот эта вот штучка. Хорошо, мы создаем новый, типа... F-вектор, значит... Хорошо, да, дальше вот он, вектор. Point, до свидания. Все. То есть сделали все как по гайду, вот это вот работает, смотри. Да, но вот эта вот штука работает, смотри. То есть тут он его находит, то есть все с ним окей. А вот через точку не находит. Мы же правильно поняли, что мы тестим? Окей. Окей, создаем вектор. Вектор equal. Этот, допустим, location. Хорошо. Во-первых, ругается. Вот. Окей, хорошо. А теперь мы создаем вот это тут, обращаемся к нему, что ли, вектор. Дат. До свидания. Работает он так. Чего не работает у меня все, короче. Вот, а вот эта вот штука работает сразу, то есть он понимает. Через точечку нифига не делает, если я вообще правильно понял, что мы делаем. Блин. Хорошо, шлепнули. Фу, шлепнули, вот тут шлепнули. Или не тут шлепнули. Через чат не пояснишь, понял. Короче, это работает, но я дурачок, я не понимаю. Все, я понял. Я понял основную мысль. Все. Все, мы на этом сошлись, хорошо. Потом когда-нибудь подрастем, станем умнее и все поймем. Так, Может и не работает. Ну ты молодец, конечно. Ну, типа, наш девиз непобедим, да. Не буду продолжать. Так, в общем, идем дальше. Мы типа посмотрели тут. Что у нас дальше за видос у него? Ух ты, 29 минут. Это прикольно. Еще будет мощно. Подожди. Инпуты новые. Но инпуты мы, кстати, тоже умеем. Сейчас я... Слушайте, ну давайте скорость хотя бы я в 1.1 поставлю. Ребят, потому что я с ума сойду. Так.
Let's add some input code, because we have talked about the most basic things about setting up a C++ class and how to then connect that up to making a blueprint and how to put that into the world, all that kind of stuff, how to add components to your classes. But now let's make some actual gameplay, because we have this template here in which we can click around, have a point and click movement system, but that's not what we want. I just make this as a template project because it's the closest to what we're actually going to end up using.
Не, подожди, мы ивенты умеем, причем здесь инпуты?
So what we want is we want to move around
инпуты делать.
and those don't do anything in this case. So let's open up the code that we already have pre-generated, see how that is built up and how we can change and add to that to make what we actually want. If you come over to whatever your project is in VS Code or whatever IDE.
Подожди. Сейчас сами залезем. У нас есть вот эти вот input actions, да? Input action, то есть можно его сделать. Только прикол в том, что он будет по-старому сейчас показывать, как через input и через project settings, по-моему, там как-то делалось, или он новый будет показывать.
You use, you want to look for your player controller. You can also put this code directly on your player character. It really works either way. Player controllers are meant to do this kind of stuff. This will take your inputs and pass it through to the pawn that you are possessing, which will be your player character. And this way you can very easily switch between characters you're controlling because all of the input is getting registered through the controller rather than directly on the player itself. For some type of games, especially since we're making a twin stick shooter, maybe you want to have multiple unlockable characters, and maybe at some point we decide actually maybe we want to have a ability to switch between characters, right? Maybe we want to make a Mario Odyssey type mechanic where we can capture other enemies. At that point, it's literally as easy as just saying, okay, now we are possessing that one, and all of our movement code is on our player controller, so we don't have to add that same code to a million different classes. So that's why we use player controller. Anyway, once you have that player controller, you're going to want to make a function called setUpInputComponent. We'll talk more about virtual and override methods later, but it's important that it's this exact name, because this is overriding a function that exists on the parent of this class. Again, we'll talk a little bit more about that later, but if you get what that means, you'll understand why it's important to give it this exact name. For now, just give it this exact name with this exact capitalization and we'll move on. We have the super setup input component. I do believe we talked about that last time. This just means that everything that's in the parent version of this function will run first, and then we can set up our input bindings. And here is where we're going to make our things move. Because right now it's setting up the mouse input events, which we have an enhanced input component, which is a component that exists on the player controller, which we'll talk about in a minute. That has a function called bind action. That takes in a input action, which is a asset that we can make in the engine. It takes in a event type, whether we started this input action. So for a left mouse click, for instance, whether or not we pressed it down or stop pressing it or whatever. Then it takes in a object that is pretty much always just going to be this, and this just means, well, this object. So if you're in the world and you have 20 different instances of a controller, for instance, if you're doing a multiplayer game, this is just a keyword that means that whenever an instance of this class executes this code, it will just refer to itself and not to any of the other instances of it that exist within the world, or any other object for that matter. And then we have a address of. Remember this from the pointer video. This will give you a address of something, a memory address, and then we have a function name with a class. So what this will do is when we start this input action, this object will run this function. Make sense? No? If it doesn't, go back, pause for a moment, think about it, re-listen to what I just said, because this is very important. Because this we're not going to actually use. We're going to put in our own bind actions. But for that, we're going to need to make our functions that we're going to run when those actions are done first. So let's comment away all of this code here, just so that it doesn't run anymore, and do the same thing here. If you're using VS Code, by the way, that is Alt, Shift, and A will comment out all your selected code just like that. It's a very handy little thing. And if you then do that same shortcut, it will uncomment that code again. That will save you a lot of heartache going forward. Do remember. I could just delete it, but this is the wonderful thing about working with traditional code, is you can just comment something out if you're not sure whether or not you're going to use it in the future. Let's make our function. We're going to make a function to just move us around. Just very simple, and we'll worry about animation and stuff later. That's mostly going to be separate from using C++ anyway. So find the corresponding header file, and here we're going to make in our either in protected or private. I'm going to do it in private now because I don't think we're going to make children of this anyway. So protected probably doesn't even matter that much. Let's just do it in protected anyway. I don't really care. We want to make a function called void, and we'll just call this move. This one you can call really whatever the hell you want, because we're not overriding anything. This is just, we're going to be using this function to move around. In that, we'll need a f input action value, and that will take in the memory address of a value. If you keep getting an error here that it's an undefined type or whatever, scroll up to the very top of your header file and see if you have the line #include input action value.h. We'll get a little bit more into includes and header files in maybe the next video or the video after that. Let's create a definition for that. And now we can start coding this actual function. So we're going to need to get a couple of things. First and foremost, we're going to need to get a f vector 2D out of this, and we'll call this the movement vector. We'll set that equal to whatever this value is. This input action value can have a bunch of different types of data in it. It can have a bool in it if it's just a simple button, like the X button. Is the X button being pressed currently? If we map that to it, this input action value can be used to get a bool out of it. But we're going to map this to an analog stick, which means that we're going to get a vector 2 out of it, or a vector 2D, something with an X and a Y value. How far in the X value do we have our analog stick tilted, and how far in the Y value do we have it tilted? So we can simply say we want to use our value and get something out of that, but now we still don't know what to get out of it, and we'll also get a error here, and that is because this is a template function, and in a template function
Ничего не понимаю, что происходит.
These little brackets in there.
Ну, понимаю, но не понимаю.
The type that you want to use with this function. So if you want to get a bool out of this, we put in a bool here, and that will work perfectly fine most of the time. For our purposes, we want to get a vector 2D out of this. So now we have this vector 2D here, which is going to get set to whatever our movement input is. Then we need to add it to the actual character.
Подожди. Он прыгает со знаний на знания, ну типа, блин, мы только что выучили, точнее, ты только что объяснял, что такое ссылки, объяснял вообще, как просто объявлять переменные в движке, и тут ты фигачишь, типа, мол, такие вещи, как value.get vector 2D, типа, мол, ну, я понимаю, что он сделал, но вот, типа, мол, объяснить, что так вообще можно было изначально, не?
In a movement, because we have a value, how and where we need to move now, but that's just a directional input. We don't have a speed, we don't have anything to tell the character to actually use that to move, so let's do that. We can do that with a function called getPawn. If you're doing this directly on your character, you don't need to do this because you're already on a character, which is a pawn, so you have direct access to this function that I'm going to use. But if you're on your controller, a function called getPawn, If you're doing this directly on your character, you don't need to do this because you're already on a character, which is a pawn, so you have direct access to this function that I'm going to use. But if you're on your controller, like I am, you want to get pawn, which gets you a pointer to the pawn that you're currently possessing, and then we want to add movement input. This function takes in a couple of things, like the world direction. Hey, we just made a variable for a direction. We can just simply put that in. We want to have a float for the scale value, and this is just a overcomplicated way of saying the speed at which we're going to be moving. So let's make a UPROPERTY value for that. So that's just simply going to be a float called speed, and we will allow that to be edited anywhere, just for ease of use. So now we can put in speed there, and then the last parameter, it's a bool that decides whether or not your input should be added to your movement, regardless of a other bool that exists on your pawn called is movement input ignored. Well, that's pretty self-explanatory. Usually when that is set to true, it will ignore any inputs that you're giving. You can overwrite that with this function and say, no, just bypass that completely. I always, whatever is the case, want this movement input to be added. For our purposes, it's not going to be relevant either way, but we're going to set that to false. Now, we have a little bit of an issue because Unreal is a mainly 3D engine. You can make 2D games in it, but things like this add movement input, it expects a F vector, which is a vector with 3 axes to it, an X, Y, and a Z. And we just put in a vector 2D. So how can we fix that? Well, let's make a F vector and let's call that input vector. And that will be equal a F vector here. So we can pass in that vector 2D that we just made and just add a 0 to the end of it. And that's pretty much all we have to do there. So now we can put in that input vector here and it should stop complaining. And there.
То есть он просто, она у него, получается, в чем смысл был? Он когда сделал этот add movement input, он передал туда, значит, вот этот вектор, куда пройти. Но прикол в том, что значение было вектор 2D, то есть там 2 значения всего было. Ему нужно 3 значения принять в себя. И он, получается, создает новый вектор, в который записывает... Просто берет этот, короче, нулевую 0 ставит по z-ке, получается, она. Вот, окей.
Here we go. And it's as easy as that. This is how easily we can introduce movement. So this is the movement function. We still haven't bound it to anything. We're going to do that in a moment. First, let's go back to the header file for our controller and look for the input mappings here. So we have some class. We'll get to that's forward declaration, also probably in the next video, input mapping context, and then we have these input actions, both of which are pointers. You're going to need to add both of these into your own class as well. So you're only going to ever need one of these. This is more or less just a list of the input actions that you're going to be using. And for every new input action that you need, so every new button that needs to do something on your character or whatever, you want to add a new input action. So we have set click destination here and set touch destination. For this template, it's also implementing touch screen, which we will not be doing. And we will be making our own real quick here. So let's just copy over everything about this UPROPERTY, add it anywhere, blueprint read only, category is input, the meta is allow private access true. I didn't cover all this in the UPROPERTY video, and that is because, by and large, it doesn't matter. You can read up on it on the documentation, and it should be pretty straightforward. The only thing that might throw you for a bit of a loop is this whole meta thing, but honestly, I don't really care too much about any of that. And let's call this movement inputs. And now we have a input action called movement input, so let's bind something to that. Going back to our CPP file, I'm just going to simply copy over one of these lines again, because why would I write something that's already written for me? We'll use our enhanced input component, which should be as easy as just doing what happens here, which is an if statement first, just to make sure that nothing crashes. You make a enhanced input component pointer, calling that something like enhanced input component. You can call it whatever you want. And you do a cast checked to the type enhanced input component, and then you pass in the input component variable, which is a variable that pre-exists on the actor class. And with any new Unreal project, unless you upgrade from Unreal 4 to 5, you might need to manually put some settings somewhere in your project, which I don't know off the top of my head. But otherwise, this should by default always just be an enhanced input component as it is. And we can use the bind action, and we will not use the set click destination. We'll use the movement input here. And we will change that from triggered to, let's see what the options are. I think we want to use ongoing here because we want to continuously be moving around. And then on this object, we're going to be running the move function. And when making this function, you want to make this parameter const, which means constant. And that just tells the engine that, hey, this value we're only going to be reading. We're not going to be writing to it. We're not going to be changing the value of whatever this is. And usually that goes very well together with functions like this, where we just want to take in a piece of information, do something with it, but not change it. This is just a little bit of protection that you can build in. And for some functions, it expects a const value to go in. And now that we have set that to a const value, you can see any errors that we might have had before, which I did have an error, is entirely gone. So that is how important it can be to implement that where it needs to go. Now, you might say, hey, wait a second, we had a parameter on this function and we're not passing anything through like that. How does that work? And that is because we're using this bind action. Bind action can run functions without a parameter, no problem. As you can see here, we have the set on destination released, for instance, doesn't have any parameters. It can run that without a problem. It can also specifically run functions with a const f input action value reference that we have here. So it just automatically does that for us, which is very, very nice indeed. So let's actually finally remove all of this code here because I honestly am just getting annoyed by it. And while we're at it, we're also going to be removing the set destination and set touch destination here because we won't be using that anymore either. The same thing with the FX cursor. We're not going to be using that anymore either. And short threshold press, we're not going to use any of this, which makes this header file a lot easier to manage, really. We also don't need the bottom two here or the cached destination. So we don't need anything in the private section is really what we're getting at here. Which means we also don't need any of these functions because we will not be using all the input that has been pre-set up. Meaning that these functions here, and I'm actually going to zoom out for this a little bit because otherwise this will be annoying. We can collapse this, we can collapse this, we can collapse that, and we can delete all of that. And we can also delete that. And then on destination triggered, I almost skipped over that, but guess what? We can delete that as well. And now our whole class fits more or less on one screen again, which is quite nice. We don't need the mouse cursor either, meaning that we don't need this constructor at all for the time being. And look at that, it all fits within one screen.
Я удалил весь просто старый код и свой оставил по факту.
Now that we have that all cleaned up, let's press Alt-Control F11 for live coding. You can see I was troubleshooting the fact that I didn't have the const in there a moment ago. Sometimes it throws me for a loop too, guys. It happens. And let's go into our project settings and look for our game mode. Our default game mode is the CPP Tutorial Basics. If we look at where that is in our project, we only have a C++ class of that, and that's quite annoying. So let's make a blueprint class of type all classes, and let's make one of CPP Tutorial Basics Game Mode. We'll call this BPGM Blueprint Game Mode CPP Basic. This is all pretty basic and real stuff. So let's go through this relatively quickly. Opening up that blueprint, which apparently opened up on my second monitor. We can on the right hand side see all of our defaults for this game mode, and we want to change our player controller class, which we might not actually need to change that. We have a BP top-down player controller class. Let's see what the parent class for this is. Is that already what we CPP Basics player controller? I think that's already the player controller that we just were working on. So let's take a look. Yeah, it is. So we have our default mapping input context, which is an asset that we'll take a look at in a moment. And then we have movement input, which is also going to be an asset. There is 2 assets of that type already made. We'll make a new one in a sec. And then we also somewhere in here should have a speed variable. So let's put that to something like 10. I don't know if that's very slow or it's going to be very fast. We're going to find out. Let's look up the location of the default mapping context and open up that asset. We can see it has mappings. It has 2 mappings here, the click and the touch. We're going to be removing both of those. And we're going to be adding our own. And there we can put in these input action assets, which let's make one of those. So in here we have actions. For now, I'm just going to simply duplicate it and call this input action movement. You can also make them through miscellaneous and then data assets, and then you have them here in input actions. Let's open up the input action, and here we can see whether or not it should consume the input. Should this action swallow any inputs bound to it or allow them to pass through to affect lower priority bound actions? If that makes any sense to you, congratulations. If it doesn't, don't worry. Trigger when paused. So when the game is paused, should we still be moving around? We definitely should not. Reverse all mappings, and then we get the value type. Remember, the value type that we are using here is a vector 2D, because we're going to be using a analog stick, or might as well use WASD. Then triggers and modifiers we don't need to worry about. With that one made, we can put in our new input action in our mapping context, which we just opened up, so that it knows that whatever we're doing here, it has these settings, and most importantly, has this value type. And then we can add inputs to that. So let's add 2 inputs here, or actually let's add 4 inputs, and that is going to be A, S, D, and W. So let's get back to WASD in a moment, and first add gamepad support, because that is ridiculously easy. Anything you need to do there is add yet another input here and look up gamepad left thumbstick 2D axis. This will just pass through the vector 2D that corresponds to your thumbstick input. It's just as easy as that. You can add some modifiers to this, such as for a thumbstick.
Стоп, что-то я пропустил.
Anything you need to do there is add yet another input here and look up. It has these settings, and most importantly, has this value type. And then we can add inputs to that. So let's add 2 inputs here, or actually let's add 4 inputs, and that is going to be A, S, D, and W. So let's get back to WASD in a moment, and first add gamepad support, because that is ridiculously easy. Anything you need to do there is add yet another input here and look up gamepad left thumbstick 2D axis. This will just pass through the vector 2D that corresponds to your thumbstick input. It's just as easy as that. You can add some modifiers to this, such as for a thumbstick, it's usually a good idea to implement a dead zone, meaning that it can't go over or under a certain value, which 0.2 and 1 are pretty good deals with that. And then what you can also do is adding a scalar modifier here, and that will allow you to put in something like a base speed. We made that speed variable, and we can change that around if we want to, but this will kind of set a base for the speed. So if we say 50, 50, and 1, because we're only using the X and Y component here, that will give us a base speed of 50, and then when we use that speed setup, I think we set it to 10 before, it will be 10 times this rather than 10 times 1, 1, 1. So for any reason, maybe you want your character to move quicker in the X direction than the Y direction, you can best set that up in here. Now, let's get to WASD, because that is a bit more of a nightmare to set up compared to how easy this is. But if you just want to control a game and you don't want to bother with keyboard and mouse, this is all you need to do. Now, these are just normal keys, which is, for the purpose of the engine, the exact same as pressing the X button on a controller or the Y button on a controller or whatever. It's just a bool value, so 0 or 1. And it's going to put that value into the X component of our vector 2D, because it's just going to take that bool value, which is true or false, but we're putting it into something that has to hold a number, so it's going to turn it into a 0 or 1, and we're going to put it into something that can house 2 numbers, so if we don't say anything about what we should do with it, it's just going to put it in the first place that is available, which is the X component. For the A, that's actually quite fine, because the A and the D are about the X horizontal movement. But the A should move us in the negative direction, so we want to add a modifier to it, and we want to say negate, which is makes it negative. You can also say is player mappable, so if you want your player to be able to remap their keys, we're not going to get into that right now, but this is how you enable that, and that opens up player mappable options, and there's again a bunch of stuff that we're not going to get into right now. Then moving on to the S, this is a up and down direction, so we want to put this into the Y component of our vector, and it's also the downward Y, so it's the downward Y. Obviously we're going to need to in the modifiers, add a negation, but is still going to just stuff it in the X component. We don't really want that. So what we want to do is add a second modifier, and we'll use the swivel input axis value. And this is just a modifier that tells the engine, hey, this input is going to go into the Y component. And from there, you should be able to quite easily do the D and the W. Because the D doesn't actually need any modifiers. The D is just positive X by default. Pressing down D will return a value of 1 and it will stuff it into the X component. So we don't actually need to do anything for the D. For the W, we need to not negate it because it's a positive movement direction. We're moving in the positive Y direction. But we do need to add a modifier for the swivel input axis values, meaning that we are going to use that for the Y movement. And now that we have all of that put in, if you need to...
Ну, типа, мы это все знаем из
do
этого.
feel free to. It's quite a bit to wrap your head around. But now that we have all of that set up, and we make sure in our project settings that the game mode we just made is the game mode that we will be using by default, and we go back into our player controller and finally add the movement input action to our little array here, that should now allow us to move around. And I did actually end up messing up the directions, it seems like, and that is mostly because we have our camera set up incorrectly. So the easiest way to fix that really is just to go back into our BP player, and since we made an entirely new class, we have to add in a camera and a camera boom because we didn't do that by default. So let's take a look at where that is. Those exist in here, so let's just cut those out and then go into our base magic character and add those into the protected section, then steal them away from our camera boom and our camera here as well, and add them into the constructor here too. We do need to add two include files here, which I'm also, again, we'll talk about that more in the next video. Probably should have made a video about that first, but I wanted to get into actual gameplay. We need to steal away the camera component, one here, and the spring arm component. So let's both of those, cut those out of this file and put those into this file. And then also just steal away these functions. We're not going to talk about those functions at all, really, in here, but we'll just put those into the public section here. This will allow us to use these functions, get top-down camera, camera boom.
Вообще не слежу, что он говорит, что вообще пролетает все мимо. У меня такой вопрос. Это, конечно, он молодец, что он зашел уже в созданный этот самый, и там все поворачивается за ним. Но мне, допустим, было бы очень интересно, что он будет прописывать по поводу, как бы он реализовывал поворот модельки, потому что когда ты идешь влево, тебе надо разворачивать модельку. Ну, там дофига всего происходит, когда ты идешь влево, там вправо, допустим, да, у тебя меняются эти значения, там 0,1 туда-сюда скачет. Типа круто, что он пользуется этим самым и ну, короче, я недоволен.
In any of the children should we ever meet. And now when we open this up, we can see, in theory, anyway, somewhere around here there's a camera boom. That one we're going to set to have 90 degrees of rotation, minus 90 degrees of rotation. So it's looking at us from the top. And also do make sure that our default pawn class is changed from BP top-down character into our BP player character, this one, because that's the one we've been working on. So now that we're looking at this from the top on, let's just take this as our base and say from here we need to move up and down when we press the W and S keys, and
Вот, теперь нифига не работает.
when we press the A and D keys, and obviously that's not what's happening right here. So the best way to just go about doing this is going into our top down, our inputs, and then change these input mappings to whatever they should be. So when we press the D key is when we're going up. So whatever D is doing right now, that should become W. And as you might imagine, that means that the A should become the S. The S should become the A, and the... which one is this? I think this should become the D. And now we can move around properly like you imagine. Still no animation, there's still no aiming or facing into different directions, but at least we've got the input right. This is the most fiddly thing to get right, and we can move around now. So everything after this is going to be remarkably much easier. We'll get back to adding some more input actions at a later date once I've explained a couple of things about the engine and coding a little bit more, and we'll be adding a
Окей,
system
ничего
where we
непонятно,
can
но
use
очень
the arrow
интересно.
keys to change our direction and start firing bullets in whatever direction we might be pressing. And that will work in the exact same way that we have set up this, but we'll also be using a spawning in of actors, which we first need to make those bullet actors. So we'll get to that first. If you do think, hey, I have all the knowledge to make the implementation of the arrow keys to at least rotate the character around, do feel free to take on that challenge. You might have to look back at the video that we're going to do in the future and change a couple of things around. But hey, if you have a different implementation and it works, you know, if it works, it works. So next time we'll be back. This video has been long enough as is. I have no idea how long the final video is going to be.
Окей. Ну, блин. Такое себе. Include and casting, да, у него тут дальше идет. Ух ты ж, блин, тут оказалось больше, чем я думал, видосов. Так, ну ладно, include and casting, давайте смотреть. Давайте смотреть include and casting. Ну, я все-таки скорости немножечко добавлю, потому что я так не могу. 1.15 будет все. 1.25 и 1.15. Так. Давайте кастинг посмотрим еще. Include.
Last time we had quite the mess implementing the movement here, which was a little bit of a pain, but now everything works perfectly fine and is very easily editable. Today we're going to go over something a little bit more basic, something simpler, but something that I do want to point out and make a specific video on, and that is something C++ related. So let's open up one of our classes. For instance, our weapon. If we want a reference to our player on this weapon, how are we going to do that? We can do this through a variety of different ways. The way we're going to go about doing it right now, possibly, maybe not the most efficient way of doing things, but it does show off what I want to show off here. So let's make a protected variable here, and that will be a variable of type a actor. Actually, let's make it a character. And
Сразу вопрос для знатоков. Допустим, если мы захотели какую-нибудь штуку получить, вот в акторе номер 1 существует какая-нибудь переменная. Нам она зачем-то нужна в акторе номер 2. Ну, кастовать — это печальная история. Мы используем в блюпринтах, что правильно, интерфейс. То есть мы можем, в принципе создать интерфейс, да? Создать в нем функцию. Это уже в C++ касается. И подключить его через DTH какой-нибудь, я не знаю, как-нибудь подключить, вызвать эту функцию там, и эта функция вернет нам с путем вот этой вот как раз-таки ссылки, которую он в предыдущих видео делал. То есть а потом мы уже с ней работаем, если мы хотим получить имена, считаем данные. А если уже изменить, то мы должны, опять же, вот этой ссылкой также делать. Просто он сейчас про каст будет говорить. Каст — это понятно. Но если не кастовать... Ладно, давайте смотреть. Так, есть делегаты, интерфейс, много всего ОП через предка. Но через предка окей, это понятно, если они одинаковые. А если они не одинаковые, то там каким образом у тебя может быть? То есть интерфейс меня больше интересует. А делегат я типа, мол, вообще не понял этой истории. Зачем вообще что-либо, если есть интерфейсы? Ну, типа, мол, интерфейс вообще все закрывает, все потребности, как по мне. Самая идеальная, самая офигенная штука. Вот. Смотрим дальше.
Now, this will work fine, but how do we get a character pointer to give this thing a value, right? And we'll do that in our begin place. So if we open that up real quick, we can do this a number of different ways. Also,
так, я опять за своем подумал. Сейчас что тут происходит?
A variable of type a actor. Actually, let's make it a character. And it will be a pointer and will point to the player. Now, this will work fine, but how do we get a character pointer to give this thing a value, right? And we'll do that in our begin play. So if we open that up real quick, we can do this a number of different ways. Also, we no longer need this function because that was just for an example. And there's a bunch of different ways of doing that. But today what we're going to do is we're going to use the getPlayerCharacter function. So we get our player, and that's equal to, how do we do this? There is a library called gameplay statics, which is a bunch of static functions that you can just call, which are useful for, well, gameplay purposes, like getting a player character reference. And the way you can get those is by using a include at the top of our file here. So if we do a hashtag include, we then get all of the potential header files that we can include. Because as you might have noted in experimenting or whatever, not every file here has access to every little bit of information in every other file. If I want to go into my base weapon, for instance, is where we're working right now, just by chance, and I want to get a variable from our base magic character. Like I want to get a reference to the camera boom for whatever reason. I can't do that in my base weapon because my base weapon doesn't know anything about my base magic character. The way to give it that information so that it can use that information is to include the header file. And what this include practically means is it just says, okay, when you're compiling, just take everything that is in the header file that we're including here and just copy paste it on top. Just act as if all that information exists in this file as well. So that way we now have access to that information. And that also goes for a bunch of the components that Unreal itself makes. It doesn't include those in all the files you make because most files aren't going to need most components. So they don't need to know what those components are and what they can do. But then when you add them in yourself, you need to tell your code, hey, you now have access to the information about this new class. Like the auto-generated character that the template came with, that has a include to the game framework player controller so that it can use the information in the player controller class. It has a include for the character movement component. It has a include for the capsule component, for a decal component, and so on and so forth. So what we're going to be adding here today is going to be in the Gizmo library, and it's called gameplay statics. Now that we have included this, I can call gameplay statics, double : because we're taking something out of a static class. We've gone over this before, I do believe. And then I can get player controller or character. We're going to get character right now. And that requires us to put in a world context object. That's just putting in any object, really, or anything that is a U object, but pretty much anything is a U object if it's Unreal specific. And that's just going to look at, hey, what world do I exist in? Generally speaking, you probably only have one world, but if you have more, it needs to know what world you have. So you can just pass in this. You just want to get the world that this object is.
То есть он, получается, в эту переменную засунул вот эту вот историю. То есть когда мы здесь прописываем get player character, вот. То есть он вот эту вот ссылочку туда засунул. Точнее, это не ссылочка, это копия. Да? Вот. Вот.
Inside. And then you want a player index. Now, this gets a little bit tricky. For single player games, this is just always going to be 0. Just always going to be player 0.
Ну, это вот zero, то есть... А, кстати, а как вот такой вопрос, вот... Каким образом обращаться в мультиплеере? Же должен быть идентификатор у каждого персонажа свой как-то. Надо будет потом гайдосы какие-нибудь посмотреть. Гайды. Все по гайдам, строго по гайдам.
Multiplayer game, if you just pass in 0 here, it's always going to get you player 1. That's not ideal if you want to get a reference to player 5. At that point, you would need to pass in 6. So you need to make a variable to do something like that, and things get a little bit more complicated. But we're just focusing on single player games here. So this is the way you get a reference to a character pointer here. Just gameplay statics, player character, this 0. And now when we start the game, our weapon
Слушай, ну это вообще огонь.
easy way to reference the player that it is on. And you will see if I remove this include, by the way, and I wait a second here, VS Code is going to scream at me because it suddenly doesn't know what gameplay statics is anymore because it doesn't have that include file. Either way,
Через gameplay static мы можем также само получить и контроллеры, и все остальные штуки, которые есть у
You need
нас.
to pass in an index, and if you don't know what that index is yet, you can't pass it in. And you wouldn't know at this point. So if you're planning to make this a multiplayer game or want to have the option open to you in the future to add multiplayer compatibility, you're going to need to go through a lot of code and get rid of all this stupid shit. So we're going to actually remove that and show you the better way of doing things, which also will mean that we need to use an include file somewhere else. So in our base weapon, what we'll do is we have a character player, and then we'll also make a void function here, set player pointer, something like that, which will take in, and this is gonna fucking blow your mind, is going to be a character pointer. Pointer. We're going to point to a pointer. Whoa! And that is a little weird.
Pointer.
Stick with me here. You'll see why in a second. And we'll call this player pointer. Let's make the definition for that. And there we can just say our player is equal to the dereferenced, I don't know why this suddenly just got converted to player, the dereferenced player pointer. So we have a pointer to a pointer. When we dereference that just becomes that original pointer again. If you don't know what I'm talking about, go back, watch the videos about pointers with this context. You can point to pointers, which is a little mind-blowing at first, and generally speaking, it's something that you don't want to do, because otherwise, if you have a function that then points to this, you're going to end up with a pointer, and so on and so forth. But for right now, this will
Подожди.
So this way we can set this player pointer.
Подожди, что за прикол с миллионом поинтеров?
Again, if you don't know what I'm talking about, go back, watch the videos about pointers with this context. You can point to pointers, which is a little mind-blowing at first, and generally speaking, it's something that you don't want to do, because otherwise, if you have a function that then points to this, you're going to end up with a pointer, and so on and so forth. But for right now, this will work just fine. So this way we can set this player pointer through a function on this thing. And then when we go into our base magic character here, we want to go into our begin play. And here we have our weapon somewhere. I don't recall exactly what we called that variable. So let's look through here. Somewhere around here, that should be child actor component weapon. That makes sense. I actually named things the way they should be named. That weapon, we need to get a pointer to specifically what type of actor it is. And here we also get into something else that I'm going to cover in this video, and that is casting. If you have seen my blueprint tutorials, or if you've experienced this kind of stuff before, this should be pretty self-explanatory, but I'm going to go over it pretty quickly anyway. So we have our weapon, and that weapon has a function on it called getChildActor. So we have our child actor component, which is a component, and that component has a pointer to the actual actor that it spawns in. But there's a little bit of an issue with that, and that is that this is a pointer to just a regular old actor. This could be literally anything. This is just an actor. So when we make a variable out of this, we can only make an actor variable out of this, right? Let's say we want to make a character out of that. It's going to scream at us, because you can't just say, hey, this character called, let's say, character, without spelling it out fully. You can't just say, hey, this character is going to be this actor, because they're not the same type. An actor isn't a character. A character is a child of an actor, but you can't directly put these into each other, because that's just not how that works. So what you need to do instead is you need to get this actor and cast it into a character. And all that means is that it's going to try to put the actor into whatever class you're casting to. And if that succeeds, so if the pointer to this actor points to an actor that happens to be a character, that cast will succeed, and it will create a variable that points specifically to a character. And now suddenly you will be able to put that into this. So the way you do that is you type cast, then these pointy brackets, and then you type in what type you want to cast to, which will be a character. And then you put in a pointer to whatever you want the variable that is going to get cast, in this case that will be the child actor, to be. And now you see it stops screaming at us, because it's no longer trying to make an actor directly into a character. What it's doing is it's trying
То есть прописывается в этих скобочках тип, а потом в тех скобочках прописывается уже путь.
This will become a null pointer, and when you try to use it, it will crash your game and your engine. So whenever you want to use this, it is advised to put in an if statement and simply just if and then the variable name, we'll check whether or not this is a null pointer. If this is a null pointer, whatever is in these brackets now will not run. Well, that was a whole tangent explaining casting, because we're going to need to cast to the base weapon. So instead of a character, what we'll do is we'll cast to a base weapon, and we'll call that weapon pointer, and we will cast to a base weapon. But it's going to scream at us because a base weapon is not an identified type here, because this file doesn't have access to whatever is in our base weapon class. This header file here defines what a base weapon is, but this CPP file doesn't know that this header file here exists. We need to tell it that it exists and where it exists. That's what we do with includes. So we can hashtag include just simply base weapon, and now it will include that header file, and it will stop screaming at us about our new variable here, because now it knows, oh, wait a second, base weapon.
Подожди, а разве после того, как мы не подключили, мы не получили полный доступ к информации из base weapon, вот это вот у него, который... То есть понятно, что теперь, если мы сделали mcast, мы теперь имеем полную ссылку на этот объект, и мы можем править в одном файле то, что находится в другом файле. Объекте, да, ну так вот будем. Из одного объекта править то, что в другом объекте находится. Окей. Но если мы просто подключим вот этот вот файл, да, туда, то получается мы получим доступ ко всем переменным, которые там есть, и ко всем функциям. То есть, в принципе, в теории мы можем вызывать функцию. То есть getter-setter тот же самый мы можем вызывать. Так разве это не будет, ну, типа, то же самое, что и интерфейс, ну, почти тот же самый принцип, что и через интерфейс, просто мы напросто будем геттеры и сеттеры всякие вызывать, и все. То есть создаем в том файле какой-нибудь get, какую-нибудь переменную, и вызываем ее в другом объекте уже. И, соответственно, тот объект уже его получает, getter. То есть для этого получается, если мы хотим что-то поменять, мы setter делаем, все. Или я фигню сейчас говорю. Фу, опять не туда. Что такое?
Weapon, that is that file. That is that header file. I know what that is. I can use the information out of that. So now we can say if that weapon pointer is valid, so if that is not a null pointer, what we want to do is we want to say weapon pointer, and we want to set player pointer, and the player pointer that we're going to give it is going to be just this. Oh, and actually, what we did before here, give it is going to be just this. Oh, and actually, what we did before here, it's still good to have that explained, but we don't actually need that to be a pointer in this case, because we don't need to like change anything about this. So what we can just do is we can say we have a character pointer here, and this will already pass through a pointer. So we don't need that to be a pointer. My apologies for that. I'm going to leave it in though, because knowing that that is a thing is valuable information. Now, it's also screaming at us because this function, I apparently made this in the private section. I made it in the protected section. That makes sense. You do need to put this in the public section if you want to access it from a different class. So even though we have it included in here, that only means that this file now knows of the existence of base weapon. It doesn't mean that I can access things that aren't public about it. I still need these functions to live in the public section in order to actually access them from a different class. Which brings us to the final thing that I want to talk about. I know that this video is a little all over the place talking about a bunch of different little things, but I don't want to make a bunch of 2-minute videos about this. So we have the A base weapon we can make in our base magic character now because we have that include. But what if we go into the header file of base magic? If we want to make one of those variables in here, let's say in the protected section, I want to make a base weapon pointer and call that weapon pointer 2, something like that. It doesn't matter because we're not actually going to use this. This is going to also scream at me because even though this CPP file might have the include to base weapon, this header file does not. And as such, it's going to throw an error. So you might think, okay, let's just copy over this include that we have over here and put that all the way up here as well. And that should fix it. And you are partially right. That will fix it. But you shouldn't do that, because these header files are generally the thing that are the heaviest to run. And these are the things that are also going to take up the lion's share of the memory of one object is going to weigh, in a sense. So just slapping on a bunch of different header files onto your header file is generally not a great idea, especially since you don't actually need any of the information that is in the other header file for just declaring this variable. If you just want to...
Либо вот в DH, короче, не надо совать другие H, ну то есть другой объект.
You don't need to know what's in it, you don't need to know how to use it, because only the CPP file needs to know how to use it. The header file only needs to know that it exists. You can do what they do up here and simply type the word class in front of it. And that just tells the compiler, hey, this variable type, you might not have any idea what's going on with it within the context of this file. Just know it's a class. That way the compiler knows what it needs to know for this file. It can compile, it won't throw any errors. And then in the actual implementation in the CPP file, that is where you put the include, because there we actually need to get stuff out of that class. We don't need to do that in our .h file. So that's a little bit of everything. We talked mostly about include files. We talked a little bit about casting. We talked a tiny little bit about pointers, just because I need a place to mention it. And this video is just kind of a wishy-washy thing of things you should probably know before going forward. So next time, now that we have all of this stuff out of the way, I think it would be a good idea to start working on the bullets that we're going to be spawning.
Окей, мы это разобрали. Что у нас дальше? Ух ты, подожди, а дальше что? Как тут? Вот time... Так, ладно. Spawning actors with CPP. Вот это вот полезная инфа будет. Так, стоять. Ну-ка, вернись. Так, а потом у нас тут... у него маленькие видосики идут. Да, относительно маленькие. Так, давайте сделаем небольшой перерыв, 5 минут, наверное, плюс-минус, и продолжим. Так, продолжим. Надо посчитать. Посчитать надо. Так, мы сейчас проходим этот, да, потом у нас, допустим, здесь у нас 20, 35, 45, 55, час 05, 65, ладно, 70, 80, 105, 135. Это ж, блин, 155 и этот самый 180, то есть на 3 часа почти мы оставляем, да? Но у него тут полезные вещи. Окей, ладно, давайте этот посмотрим и посмотрим, что будет дальше. Сейчас у нас spawning actors with C++. Вот.
Let's talk about spawning in the bullets for our game here, because we have our movement, at least in large parts, done, but we want to be able to spawn in our bullets. And for that, we need an actor to be able to spawn. So let's go into our C++ classes here, because we have in our public classes a base bullets. So first and foremost, let's make a blueprint class based on that, and we'll call that BP simple bullets. This way we can actually easily spawn in bullets and tweak all of their values and so on and so forth. So let's go into the C++ class for that, because we'll be able to see there's nothing in this blueprint class, and that is because this C++ class is entirely empty. It has a begin play, it has a tick, which both of those are empty. It has a constructor, which doesn't really have anything in it either. So real quick, we're going to go through this. This is all stuff we've done before. We're going to be adding a static mesh component, and we're going to be adding a sphere component. The static mesh is for the mesh of the bullet. You could also use a Niagara component if you want to make your bullet a particle system rather than a mesh. Actually, I think we're going to do that because it's all magic, right? We're going to be doing magic, so using a particle system makes a little bit more sense to me. And then a sphere component, which is going to handle the collision. So in our protected section here, let's add a U Niagara component. And capitalization is important. Pointer, and we'll call that bullet FX, which will be the effects that the bullet uses for display. And as we discussed before, we don't have the include for the Niagara component here, so we'll just have to tell the compiler that this is a class. And also do make sure, I personally always like to just copy the names from the documentation, which I have open on the other screen over here, just to make sure I didn't make any typos. And then we also want a U sphere component, which is probably going to result in a similar error in a moment here. And that will be our collision sphere. And then our bullet effects will be able to create default subobject of type U Niagara component with the name effects, something like that. Doesn't really matter what name we give it. And then we'll use our sphere collision. I called collision sphere, not sphere collision. That makes a lot of sense. And we'll do much of the same thing. That will create a default subobject called the collision sphere. And for that one, we're actually going to also use our collision sphere here, and we're going to set up attachment. And you will note that we actually don't get any suggestions here for what we can do with this class type, and that is because we are missing the include. Sometimes you won't get errors if you don't use includes, but you do miss out on all the IntelliSense, so still nice to just add them in. And now we can set up attachment, and we can attach it to our bullet FX, just like that. That way it will be parented to our bullets. And it doesn't really understand what a Niagara component is either, so we'll have to include that one as well. That way it understands that the Niagara component is also a scene component. And as a matter of fact, let's set root component to the bullet FX. Might as well. And for now, that's all that we're going to do for the bullets. So let's live code. And now in our simple bullet, we have a root component, which is our FX, and we have a collision sphere. And neither of those are editable because I didn't make them into editable UPROPERTIES. UPROPERTY edit defaults only for both of them, and let's try again. And now I can actually set a system here, and I don't have any particle systems at the moment, so for the time being I'm just going to make one off screen real quick, a very simple one that's just a bunch of circles spawning in. But at least now we can use this particle system here, which can we scale that up? I think we can, which also scales up the collision sphere, so let's decrease the size of that again, so it's about the size of our bullets, and that doesn't look great, but it's better than nothing. Anyway, let's get back to our code, because that's what we're here for at the end of the day. And with our code, I think we're going to open up our base magic character, because our enemy character and our player character, as you might recall, are both children of this magic character, and the magic character is going to have the function for shooting, which will get driven separately through the enemy and the player, but they both have access to it, because we're going to be putting that in the protected section in here. So we'll just make a, we can just make a void function called shoot bullet, and that will work more or less fine. What I'm going to do though, is I'm going to, instead of making this a void, I'm going to make this an actor return type. If you're that new to programming to the point where you don't know what that void we've been using means this entire time, you're about to find out. I'm going to go over it real quickly because this is a useful thing to be able to do. So we'll create a definition, and you'll see we get a return here. And that means that when we use this function in another place in our code, that line of code will act as whatever we put into the return here. So for a simpler example, I'm going to just make a very simple example. I can make a float function called add to numbers, and that takes in a float A and a float B, and that also asks us to return something, and what we'll return is A plus B. And now if I, for instance, in begin play, use that add to numbers function, that will be treated as just a float variable that we can put into somewhere. But let's say I just want to make a float value can be equal to add two numbers, and then we can put the two parameters in here, so 5 and 19, for instance. Now this line of code will just effectively be equal to saying 24, because what it does is it sees, hey, we have a function here, it's going to run that function and see, okay, we have A and B, A is 5, B is 19, add that together, throw that back into here, and just put a 24. That's what return types do. So with an actor return type, we can make a function that whenever we spawn in a bullet, we can have a reference to that bullet. And I just realized I made a mistake because this should be returning a actor pointer and not just an actor. You don't necessarily have to do something with that return type though. You can just use a function for its functionality and not use its return. But a function with a return type always needs to have.
Я вот что заметил, чем дольше у него видео, тем он меньше тратит времени на объяснение.
At the end of the function. And what we're going to do here is we're going to make a actor pointer, spawned actor, and that will be equal to a function that also has a return type a actor, and that is spawn actor. And in order to spawn an actor, you first need to use the getWorld function here, which will get you a pointer to the world. And the world will be the thing that's capable of spawning in actors. So we can say spawn actor here. And there you want to pass in these pointy brackets, the type of actor that you will be spawning. You can also leave that out and specify that within just the normal parameters. If you want a spawn actor function that can spawn different types of actors for whatever reason, you can do that. It's a little bit more bothersome. So the way we're going to do it is we're going to just put it in here and we're going to spawn a base bullet, for which we will need to include the base bullet because we don't have an include to that yet. So let's include base bullets. And then as the parameters, we need something called the actor spawn parameters, which is a variable type as well. So let's make those as well. That's a type called f actor spawn parameters, and we'll call that just spawn params. And in spawn params, we have a bunch of different things, like the instigator, meaning what actor spawned this new actor in, and that's going to be just this. That's relevant for things like scorekeeping, right? Because if I spawn in a bullet and that bullet then kills another player or some enemy, especially in multiplayer games, you want to know who that bullet came from that did the killing. So you want to keep track of this kind of thing. And there is a bunch more of these that can be useful, like the override level. If you want to spawn this actor in a specific streaming level, well, that can be very, very relevant because by default, these will just spawn in the persistent level. So if you want the actor that gets spawned in to be in the same streaming level that you yourself or the actor that spawns it in is in, you will need to use this override level. Something that I personally, with my game, kind of forgot to do for the longest time, and that becomes an issue. And then the spawn collision handling override, which is just telling, hey, if I try to spawn this thing and it ends up overlapping with any existing collision, how should I handle that? Those kind of things you can set up in the spawn parameters. For now, we're only going to set up the instigator. So let's put in our spawn params here. And then the parameters before that, there's a couple different versions of this function that you can use. The one we're going to be using is this one over here. So first you pass in the location that you're going to spawn in, then the rotation, and then the spawn parameters. So for the location, what we're going to do is we're going to add a specific component for where the bullet should get spawned from. So let's add a UPROPERTY here for edits anywhere. Edit defaults only, I think, would be better. So let's edit defaults only. And that will be a uScene component, which is more or less just transform data. It's just as easy as that. A scene component is a component that has a transform and nothing more. All the other components that we're using here, like the camera components and the spring arm components and the child actor components, all are children of the scene components. But if you just need to have a transform somewhere for a purpose like we're using it right here, just making a scene component just gets you a component just refers to a point in space and really doesn't do anything else. And we'll call that spawn location, as easy as that. And then going back up here into the constructor, at the very bottom here of the constructor, we will now create default sub object uScene component, and we'll call that bullet spawn points. Now that we have that, we can just get that spawn location and going back to our shoot bullet function, and then we can find the get component location, which returns the location of the component in world space. That's very important. There's also one that gets you the local location of it. You don't want to use that. You want to get the position in world space. So we get that. And for the rotation, you can do a couple of things. You can say F rotator double colon and just 0 rotator. That will work as a, if you're familiar with Unity, this is just quaternion.identity. If you're not familiar with Unity, this is just something that says, hey, rotation's simply just 0. It's just, this is a way to give a rotation, because you do need to give a rotation without actually needing to input anything in the value. What we're going to do is we're going to match the rotation for the thing that we're spawning with the rotation of our actual character, and that is simple
Тяжко как-то.
Rotation. And then we have all of our spawn parameters done, I do believe. What you can do if you have a function with a lot of parameters in it, by the way, a nice way of dealing with that is just putting the parameters under each other like this. Empty space in code like this, just like enters, extra spaces, gets ignored by the compiler anyway. So it's fine. Don't forget to add the semicolon though. So now we have an actor pointer here, which is going to get set to point to whatever actor we just spawned in. And we need to return an actor pointer, so we can just return that actor pointer without the parentheses.
Нормально.
It seems like we might have already had a shoot function, which I've entirely ignored.
Андрей, тяжко не в том, что здесь происходит. Здесь все окей, здесь все понятно. Я просто как бы смотрю на то, что здесь происходит, и я представляю, как бы, в блюпринтах все это происходило. Но по аналогии тут все окей с этим, но чувак такой прикольный, короче, вот. Мужчина прикольный очень. И оно тяжко как-то для понимания. Вот его вот эти вот предыдущие ролики, которые были коротенькие, там все было понятно и интересно. Здесь как-то оно летит, как-то все мимо. Я смотрю, что-то там понимаю, а потом бац, какая-то строчка появилась, уже не понимаю. В общем, но мы досматриваем. Там видно будет.
But that's fine. That's entirely fine. Let's just remove that, because the one we just made is the one we're going to be using. Well, there's one big issue with this still, and that is it's always going to spawn in this C++ class, and that's not really what we want. What we want is to use this C++ class, a base bullet, to make blueprint classes that we can have varying damaging amounts or whatever on different particle systems and spawn in those blueprint classes. Luckily, that's actually quite easy to do. So let's get back into the header file here and make a T subclass off. And then these two little pointy brackets, because we're going to be using a template. Well, it's not really a template function, it's more of a template variable.
Уже пользовались, да, помните,
And there we put in whatever C++ class we want to choose a blueprint class from. Because what this is going to do in Engine is, when we want to give this a value, we can pick from a drop-down list of all the blueprint children from a certain C++ class. So if we put in a base bullet here, and then call it bullet to spawn, and subclass is not with a capital C. I always make that mistake. I feel like it should be. And we make that a UPROPERTY that we can add it anywhere. You really should probably put this at a default only. So let's just do that actually. Now we can put that in as a parameter in this function as well. It's going to be the first parameter, and now it will spawn in whatever blueprint actor is getting set into this variable. So let's recap what we've just done. We've made this function here, which will return an actor, and that will be the actor that we spawn in. We made the spawn parameters to make sure that the instigator is set to the magic character that actually spawns in the bullet. Then we make a variable for an actor pointer that we're eventually going to return here, which will be the actor that we spawn in. The spawn actor takes in a template here, and that is just telling us what type of actor is about to be spawned in. Then for the parameters, we put in the actual class that we're going to be spawning in, which in most cases that's going to be a blueprint class, because you want to be able to tweak values very easily in Engine. So even if you don't have a bunch of variety of bullets, it's very nice to have just got a blueprint class where you can just say, okay, now this is worth 5 damage without needing to recompile everything. Then we put in the location, which is going to be set from a scene component that we just added. Then it will copy the actor's rotation and use those spawn parameters to spawn everything in. That's how spawn actor works. Now let's map that to a button, because we still don't have a button, which of course we will do on now.
Звук, звук есть, я просто думаю. Звук присутствует, я просто думаю. Вот это ж он делает вот ту же самую историю здесь вот в этом актор спаун. Это я думаю. Не все же время трындеть, правильно? Это я в блюпринтах могу трындеть, потому что я там плюс-минус что-нибудь шарю, да? А тут надо подумать. А думать и трындеть это тяжело. Вот. Поэтому замолчал. Я вот не пойму, вот он, хорошо, спаун актор идет, дальше классом он определяет актор base bullet, да, это идет у него класс. А bullet to spawn он передает, это что он передает, что это за фигня? Что это у него за параметр там такой, bullet to spawn? Это типа шаблон класс. Так, давай по блюпринтам. То есть bullet to spawn это вот этот вот класс имеется в виду. Он выбирает, да? То есть вот он, bullet to spawn, это вот он передал эту информацию, потом spawn location и в get component location, это он location передает, ну и actor rotation, он, естественно, вот rotation передает. Вот, scale он пропускает, spawn params, он, скорее всего, в spawn params он передает scale. Вот. Но получается, он два раза на класс ссылается. То есть spawn actor идет base bullet. Как в BP и хз. Ну, блин, это одно и то же. Слушай, он вызвал ту же самую функцию spawn actor. Вот. И она точно так же работает. То есть он туда же передает все эти данные. И этот самый... Как ты можешь знать плюсы в Unreal и не знать блюпринты? Это как так работает? Так вот, он вызывает ту же штуку. Вот, и передает. Только я не понял, а почему вот тут вот base bullet туда и опять bullet to spawn. Тут я чего-то не понял. Base bullet это его именно вот этот актор, то есть пуля вот этой вот снаряда. То есть, окей, он передал его. Bullet to spawn это скорее всего... Он же там брал ссылку на актора, вот этот вот, на этого, да, это скорее всего она, но все равно я не понял, почему два раза. По факту две ссылки, то есть на общий и не на общий этот. Что-то какая-то тяжко. Ладно, будем считать, что процентов на 80 мы все поняли, что здесь происходит.
So let's map that to a button, because we still don't have a button. which of course we will do on the player controller that we made last time. So we had this whole input system that we have here, and that was just going to add a new bind action. It's nice to add some comments here to say that this is movement bindings, and then we'll add another comment somewhere here, which will be shooting bindings. And I'm going to skip over a lot of this because this is literally what we did in the last video. So I'm just going to copy over this and change the name to fire input. Then I'm going to make a void fire bullet function, which takes in a input action, because we're going to be using that eventually. At the moment, we're just going to, whenever we press a button, it'll spawn in an actor. I will change that to as long as we have a certain key pressed in, it will shoot in a certain direction in a future video. That's a little beyond what we're doing right here today. This video is long enough as is, so I'm going to speed through this a bit more. So now that we have that, we can copy over this entire setup where we have the enhanced input component, bind action. We'll use the fire input, the event will be, I think triggered will do just fine, and then it will run the fire bullet function when that input is triggered. And in fire bullet, what we're going to do is we're going to, let's see, do we already have the magic character included? No, so we'll hashtag include the base magic character. So let's also make a variable for that. So class a base magic character, which will be our player character. At begin play, we're going to give that a value. So that will be our player character will be equal to a cast to a base magic character. And for the parameter there, we'll get the pawn. So what we'll do is we'll get the pawn. We'll check, hey, is this pawn a base magic character or not? If it is, we'll put that in the player character variable here, which apparently I misspelled something about. Oh, we need that to be a pointer. That makes sense. Again, as I mentioned in my video about pointers, especially if you're rushing, like I'm right now, you might forget this sometimes, but the engine will scream at you when you do it wrong, and you'll just realize, oh, wait a second, that needs to be a pointer. Now that we have that player character variable here, we're going to, first, every time we try to shoot, we're going to check if this is a valid variable or not, otherwise the engine will crash, which you don't want. And if it is valid, we will shoot the bullets, which needs to be in the public section of the header file. Because right now, as we can see, it was in the protected section. We're going to move that to the public section so other classes can use it, like the player controller. And now all the errors are gone. So real quick recap again, we made a new input action here, and whenever we press that button, which will set up an engine in a second here, we will run this function, fire bullet, which will just use our player character reference that we just made and use the shoot bullet that we've just programmed in, which just will spawn in a bullet. The bullet isn't even going to be moving or anything. It will just spawn in a bullet actor, and that is all that it will do at the moment. But I do believe that is all the C++ code that we're going to be doing for the time being, so let's live code. There is a bunch of stuff that's going wrong, and the issue I think is the fact that I didn't forward declare this, so the compiler has no idea what base bullet is, because again, this header file doesn't have an include to it, so we need to forward declare it.
Где мы Так. Трам-пам-пам, трам-пам-пам, трам-пам-пам. Где-то это делали или нет? Или мне привиделось? Да, вот TSAP класс. Ладно, мне это ничем не помогло
And
дальше.
that fixed just about everything. So let's go back to our simple bullet here. That is fine. And then in our player controller, which we have somewhere, surely, we have the new fire input. So let's copy over the input action for movement and call that fire. We can drag that into there. We also want to open up our input mappings context thing and make a new mapping for the input action for firing. Fire. can drag that into there. We also want to open up our input mappings context thing and make a new mapping for the input action for firing. And there we're going to, for the time being, just use the up arrow. Again, eventually we will add in context for shooting to the right, shooting to the left, shooting to the bottom, and whatever. That's going to take a little bit more work, and that's going to be probably its own separate video. For now, up is just going to be shooting. Finally, in our player, we can define our bullet to spawn. And you see, as I mentioned, we have our bullet to spawn. And when we drop this down, we get the base bullet, which is the C++ class, but we also get all the blueprint classes that are children of that we can select here from a drop-down menu, which is, again, fantastic. I love how that works. So now that we'll spawn in at our spawn location, which is a scene component that we have here, and we will just spawn that someplace in front of our character, somewhere like there. And now, if all's gone well, we can press the up button and we can see it spawned in a whole bunch of these bullets, except it spawned them in at a weird position, maybe. It all spawned them in right there. That's because the spawn location is never attached to anything. So let's real quick go back here. These are things that do happen. So the spawn location, we can set up attachments. Let's do the mesh. It doesn't really matter what you attach it to, that just makes the most sense to me. So now when we go back here, we'll see that, let's recompile that. Or sometimes you just entirely need to restart your project because it does weird stuff. Now it is attached to the mesh, so we should be able to spawn them in front. Let's see. We do. We spawn them in a weird location, though. Why would that be?
Он там съехал,
because that is actually where I put the point. So it spawns exactly where we think it should spawn. Now, at the moment, it spawns them in as long as I hold it down, which obviously, yeah, that's not really what we want to do. But at least we're spawning in these actors when we press the right button. So we could change this from triggered, which will continuously keep spawning these things in, to, I think it's called started, which will only spawn them in, only.
Ну, интересно, что у него в Movement Bindings, во-первых, залетает Fire Input. Это во-первых. А во-вторых, я еще не придумал. Вот, докопаться решил, так сказать. Еще раз. Если у нас ссылочка наша существует, мы кастуем. Ой, кастуем каст. Checked has input. Input. Компонент. Когда срабатывает эта штука, то мы делаем нашу функцию. Ага. То есть мы и туда ее шлепаем. И таким образом мы получим. Все, я понял. Все, в предыдущем уроке я не понял, когда он объяснял эту же штуку. А вот здесь я уже начинаю понимать, что он делает. Повторить, конечно же, не смогу, но хотя бы на уровне понимания. Окей, дальше.
Trigger that function when we initially press it. But for the eventual gameplay, we're going to want this functionality, which is going to change things around a little bit. So next time, before we actually get into all of the more complicated shooting things around in the direction that we want to shoot them around in, we're going to talk about timers and have a timer that whenever a bullet is fired is going to disable our ability to fire bullets, start a timer, and once that timer runs out, it will enable us to shoot another bullet. That way we can hold down the key and it will only shoot a bullet once every third of a second, or once every 2 seconds, or whatever your fire rate will end.
Ну, блин, таймеры это очень интересно. Подожди, таймеры это очень интересно. Мы там много чего полезного узнаем. Блин, уже дофига. Уже пора. Пора бежать, так сказать. Так. В общем, дофига сегодня мы прошли. Сколько? 7 видосов глянули? Да, 7 видосов просмотрели. Их всего 18. Там дальше видосы Go Last. Блин, таймеры 18 минут. Это где-то на полчаса сейчас еще минимум сверху. Ну ладно, погнали еще один, этот самый last видос. Вроде бы успеваю. Так, да, давайте не отвлекаться. Все, таймеры, срочно, супер важная информация. Таймеры, всем смотреть. Всей семьей, всех зовите. Таймеры пошли. Это штука, что он вперед летел. Это мы знаем из блюпринтов. Звук. Ёп! Блин, всю минуту заново. Звук забыл вам включить. О, все, фейл, все заново. Пересматриваем.
And they spawn in literally every frame as long as we hold down the shooting button.
Fail.
Both of those aren't exactly ideal. So let's fix both of those real quick in today's video. The majority here is going to be about setting a timer to make sure it only lets you shoot every 0.2 seconds or so. But before we do that, let's actually go real quick into our bullet class and add another component to that. That's going to be a UPROPERTY, and that will be a class named UProjectile Movement Component, which is a very big name, so I'm just copying it over from the documentation. And let's call that projectile movement. And of course that needs to be a pointer, something that's so easy to just forget. And we can add that in here, so we'll just
вот он, вот этот такой вот
create default subject of the type, which again I'm just gonna copy paste that because that word is way too long with way too many chances to make a typo. We also need to use its include, and then we can also set up some of the defaults in here as well. We can always change this in engine if we want to, but we want to, for instance, disable the gravity scale. So
да, там на gravity надо отключать, она изначально включена.
Zero, so that it doesn't fall through the floor. And in theory, that should be all we need to set, because you can also worry about setting its direction and its speed values through code like here. We're going to worry about that a little bit later. But let's make a UPROPERTY here real quick for the speed and set that to public, because we might need to use that from another class. Now, let's get into the whole timer business, because as it is in our player controller over here, we have a input action that is bound, set to event triggered, to fire bullets whenever we do this input action, which is set to a certain key. The issue is that it now spawns in a bullet every frame, as we could see at the start of the video, and we don't really want that. We want to have a way to see, have we fired in the last X amount of time? And if we have, we don't want to shoot a bullet. So let's go into our player controller's header here, and we can in the protected, or hell, even in the private section if we wanted to, simply make a bool called can fire. And we want to make sure by default that is set to true. So it can always fire unless we tell it, hey, stop firing. If we go back to our shoot bullet here, our fire bullet, we first check if the player character is a valid pointer, if it's not a null pointer. In that same if statement, we're going to put two ampersand signs to check for two different conditions. The other one is can fire, the bool we just made. So this has to be true in order for the shoot bullet function to be able to run. Now, after we run that shoot bullet function, we set can fire to being false. So now after we fire once, we'll never be able to fire again. And that is because when this is set to false, this if statement no longer fully holds true, and this code will never run again. So we need to put something in place to set that bool back to being true after a certain amount of time. And that is where timers come in. So timers, we need to make a separate function that we can tell the engine to run after a certain amount of time. You can't just say wait 5 seconds and then do some more code. You can only say, hey, in a certain amount of time, run this different function. It's not like what you have in Python where you can say, I think it's called sleep, just sleep X amount of seconds and then move on with the rest of the code. You can't really do that, which is too bad because that would be fantastic. So let's also create a float here And realistically, this would be a float that you want to have on the weapon, not on the player controller. But for now, let's keep it simple and say time between fires. And we will make that a U property that we can add anywhere, so that we can easily try and play around with how much time that takes.
Кстати, вот такой вот вопрос сразу. Ну, я понимаю, он, скорее всего, для примера это делает именно так, а не как иначе, да? Но вот эти вот can fire и time between fires, они же все должны быть... Ну да, он их не в привате делает. Ну, короче, к ним доступ надо будет иметь. Короче, к ним доступ надо будет иметь.
Default, let's set that to 0.
Из других объектов имеется в виду.
So the code knows that we're talking about a float here. Making a timer. Well, we do have a little macro. If you have the plugin that I told you to download at the start of the series, which is utimerset, and that just puts in the code that you would otherwise have to write. So what you need to do is you need to get world, just like we needed to do for spawning in Actor. And then from that, you can get the time manager, which is an object that's all about the time that goes on in your world. That has a function called set timer that takes in a timer handle, which we'll need to make in a moment. A object, which is just going to be this. That is the object that you are going to run a function on in a certain amount of time. The address of that function, the delay time. So for us, that's going to be that variable that we just made, and whether or not this should loop. So maybe you want a timer that does something every 5 seconds from the moment it's first fired. In that case, this would be true. By default, this is false, so you can just leave it off, I believe, and it will just be false by default. So let's make our way back. We need a class here. Well, that's the class that we're on right now, so that's easy. And we need a function. Well, let's make that function and call that void reset can fire. And this function is really going to be easy because it's literally just setting can fire to being true again. That way, whenever we get back to this again, this if statement is now completed and we can shoot the build again, set it to false and run this timer again, after which we set it to true and the whole thing can run over and over and over again. So we'll put in reset can fire for the function here. This is just this, pretty much always going to be just this, the object that you need to put in because you're running a function on this object. Then we need to put in a timer handle, and that is a variable type called fTimer handle, and we'll just call that timer handle because I think that is by default the name that macro uses. A timer handle is...
Ну, он вызвал, в принципе, тот же самый таймер, который у нас есть в нашем блюпринте, то есть вот... ну у него, кстати, function name. Кстати, привет, называется set timer by function name у него. Да. У него это как раз таки он. В чем прикол? То есть, получается, он опять get world, вот этот вот делает, get world. Потом get timer manager, и так понимаю, нужно будет include сделать. Потом set timer. И начинается, то есть... Таймер handle. Нужно указать таймер handle. У нас здесь в блюпринте только на выходе он, получается, существует. Это типа имя, грубо говоря, это имя этого, ссылка на этот таймер. То есть имя его, ссылка, я не знаю, как это назвать. Но, в общем, это этот таймер. Да, то есть handle ручка, то есть ручка таймера. Короче, вы поняли, все. Идем дальше. Потом this это как раз таки обозначение вот этого object reference, то есть где именно вызывается этот таймер. Потом у нас идет наша ссылка на функцию. Вот. Вот ссылка на функцию. Потом у нас идет, значит, наше время. Сколько мы, ну, когда таймер Точнее, когда таймер вызовется. Вот. Ну и дальше лупинг, скорее всего, и все остальное. То есть initial start delay и initial start delay variance.
Kind of
вот.
like a manager that just keeps track of, hey, am I running a timer at the moment? Because it could very well be the case that you make this as a variable on your header file. as a member, at which point these timer handles can only run one timer at a time. And sometimes maybe when a timer is already running, you don't want to allow it to run the timer again, to restart the timer until it's finished running. Or maybe you do want to reset a timer.
Хорошо, объяснил, спасибо. А ты типа этого не знал, что ли? Вот. Ты не за что обращайся, как говорится. То есть, ну, ладно, не буду показывать еще то же самое в блюпринте. Потом когда-нибудь буду использовать это. Потом покажу.
This way you can just set it and forget it. You just create the timer handle, pass it in here, and after that it gets destroyed anyway. And honestly, most of the time you do it this way. So the whole timer handle situation, not too relevant. Just you do need to do it, is the thing. Well, that's all fine and dandy, but what if instead we want to do something on a timer for which we need a parameter? Because this can only call normal functions without any parameters in them. And that's why we have setFire directly set to true. But that's a little bit messy. Because what if on this same class we also have a function for setFire that we do based on a parameter? Because it's very likely that a class like this would have something like that. So let's just change this function to setCanFire, which takes in a bool parameter for the value. And then this will also take in the bool parameter, of course, and we'll change the name here. And this will start screaming at us because this function no longer exists. But that's okay, because we actually are going to get rid of this in a second. Because you can set timers for functions with parameters. It just takes one little extra line of code. And that is, we're going to make an ftimer delegate instead. And we'll call that delegate. And that we will set equal to ftimer delegate. Double colon, we're going to be using a static function for this, create uObject, and in this we're going to take these two parameters and put them into this delegate instead. And of course, we need to use the proper name for the function here. And this will now allow us to put in the parameters for this function into this delegate. So this function takes one bool parameter. In this case, that's going to be a value of true. And now suddenly we have an object here that we can instead that will run.
Ну, сейчас, ладно, давай досмотрим.
The value that we just put in. If you're using this one for whatever reason, you do need to specifically say that looping is true or false. You can leave it off in the other scenario. In this scenario, you can't. That seems just like an oversight to me, but do be aware of that. And now we can use this function elsewhere, and we can even, if we wanted to, make another system where it gets set to false after 0.1 seconds and then back to true after 0.2 seconds in total. Because we
Какого фига у нас после запятой true относится к тому, а this относится к этому? Я не понял. Это что за фигня? Фига он это... Я понял, зачем он delegate сделал. Для того, что, мол, если в самом таймере мы хотим засунуть какие-нибудь параметры, то есть функция, мы передадим параметры какие-то входящие. Кстати, вот этого мы, походу, не можем сделать в этом. Ты понял, да? Мы не можем сделать здесь, то есть функцию принять параметры, то есть через блюпринты мы так не умеем делать. А вот через C++ мы так умеем делать. То есть если мы захотим какую-нибудь функцию выполнить там a плюс b, и a и b у нас входящие параметры где-то, да, и мы их хотим передать и запустить наш таймер, то нас пошлют далеко. Вот. Мы этого не сможем сделать через блюпринты. А вот, ну, хотя мы можем через event запустить и там функцию сделать, то есть не через function, а типа, мол, set timer by event. Вот. Вот здесь custom event, и вот здесь просто вызвать функцию, которая нам нужна, и в нее передать эти, то есть таким вот образом. Это решается. Ну, а через function name, конечно же, мы не сможем этого сделать. Вот. А тут нету, то есть такого понятия, как function, не function name, custom event и так далее. Тут у нас получается путем обычным, да? Поэтому он использует этот delegate. Но я не понял, почему... Delegate это и есть event, а бупен это этот самый... Тогда мне все понятно становится, почему он вместе с this перенес. Он дальше будет их объяснять. Но это потому, что я люблю лезть впереди паровоза. Вот, поэтому непонятно. Вот. Ну, то есть, все. То есть, вот этот вот F-Timer Delegate, это и есть вот этот event, да, так тут он, все, плюса, короче, вот это вот он так называется, да. То есть, тогда понятно, почему он this, то есть, это он обращается к себе же, вот, и там, create new object, и получается... Там этот только почему после той запятой, я бы понял, если вот set canfire, если бы там в скобочках было, или он просто неправильно написал, в скобочках true было бы, я вообще, ну типа, все понятно, почему после запятой непонятно. Ладно, давайте смотреть дальше.
We now have a much more flexible function that we can call on a timer with a parameter. So really, that is all there is to it as far as these timers go. So let's compile the whole thing here. And now we should see that we're only spawning these things every so often and not every frame anymore. We're still spawning them relatively often and they're still not flying anywhere. That we will fix in a moment. But we do have a projectile movement component on this thing. So we'll just set the initial speed. I forgot to do that to something like, I don't know, 100 and then...
Да ладно, в плюсах покажи, как ты это делаешь. Нафига ты
right now. You probably want to set
в
this
blueprint
through some
лезешь?
sort of code. But once we've done that, you will see these things actually starts moving and 100 is way too low. So let's set this to 1000 instead. And that is much better. So now we've got a character that can move around and I can just hold down this button over here and it will shoot a bullet every 0.2 seconds. And the wonderful thing about this as well is before we were spawning every frame, which is fine, kind of, maybe, not really. But since we're using a timer that just works on real world seconds, this is now also immediately frame rate independent. Even if my frame rate absolutely tanks, to a reasonable degree anyway, I will still be shooting every 0.2 seconds. So that's quite nice. Now, real quick, because we're doing this whole bullet thing anyway, I'm going to add in the other three directions as well here. So that's up, down, left, and right. And we're going to be copying the modifiers from the W, A, S, and D because those are the same directions. And you can just copy modifiers and then paste them on here. So I'm going to do that and we're going to skip over all that because that is not too interesting. You can also do it by shift right mouse for
Какое-то интересное у него управление получается.
the left and shift left click to paste. And real quick, back in our
Прям
code,
какое-то
what we
супер
want to do
олдскульное.
is we want to set our player character to face in the direction that matches our inputs here and only then fire. So we're going to split this up into two separate if statements. Real quick, we're going to check can fire only after we have already set the rotation. We want to set the rotation always, but we don't always want to fire. So we will use the player character, set actor rotation. And to get that rotation, we're going to make a F vector for direction, which I misspelled, but that doesn't matter right now. And that will be equal to F vector with a...
То есть стрелять влево, повернуться влево, стрелять вправо, повернуть вправо. Понятно.
And we will be getting a F vector 2D and adding a 0 onto that. Then we can use that direction, and you can actually very easily get a rotator out of a F vector by just putting in your F vector dot rotation, and that should just simply spit out a F rotator that you can use to set your actor rotation. So this will be relatively clunky, I will admit, because this needs a lot more polish, but this should allow us to add some rudimentary aiming, which doesn't seem to be working for our mesh for whatever reason, but at least we can actually like aim where we shoot, which that's a start. I'm not entirely sure why the mesh is.
Я не понял, какого лишего у него поворачивается в эти... Подожди. У меня там такой дебильный код. Мне как раз вот эта вот история интересна. Подожди. Еще раз.
Set actor rotation, and to get that rotation we're going to make a f vector for direction, which I misspelled, but that doesn't matter right now, and that will be equal to f vector with a value of our input action value dot get, and we will be getting a f vector 2D and adding a 0 onto that. Then we can use that direction, and you can actually very easily get a rotator out of a f vector by just putting in your f vector dot rotation, and that should just simply spit out a f
Подожди,
rotator.
нифига не понял, еще раз. Все, у меня там дурацкий код получается, там просто забей. Мне персонаж бегает, поэтому там через блюпринты, конечно, сделано все дела. Если не понял, как он получил. Вот. Ладно, нифига не понял.
That you can use to set
Словно нифига не понял.
So this will be relatively clunky, I will admit, because this needs a lot more polish, but this should allow us to add some rudimentary aiming, which doesn't seem to be working for our mesh for whatever reason, but at least we can actually like aim where we shoot, which that's a start. I'm not entirely sure why the mesh is not getting set to rotate though. Alright, I'm going to be real with you. I don't know why the difference that I programmed in worked, but it's something that we needed to do long term anyway. But now we actually do rotate in the direction that we were shooting in, and we can still shoot in any direction while walking in any direction. Now, I'll give you a real quick rundown on what I did. Is I took the code for rotating out of the fire bullet. Instead, I'm storing that in a f rotator now. So I made an f rotator variable on the header file, and I'm just setting it to that. And then I created a tick function, which is just something that every actor can have. Runs every frame. You're probably familiar with it. And I'm just setting the actor rotation in that every tick. And for some reason, that does work. We needed to do this anyway, long term, because what we want to end up doing is
каждый тик это делать.
Orientate ourselves in the direction that we're shooting in, but whenever we're not shooting, we want to look at the direction that we are walking in. So we need to make something for that anyway that runs in the tick function, which we might as well do that right now. So what we'll do is I'll make another f rotator here, and that will be our movement rotation. And in our movement, I will simply set our movement rotation variable to be equal to our input vector dot rotation. And now we just need a bool to check whether or not we are shooting. So the way we're gonna do that is gonna be a pretty hacky way, and that is we're going to just get this bind action, and we're gonna copy that over twice. And once we're going to run on started, and then once on cancelled, I believe is the one we want. And we'll simply make two functions here. Again, I'm just doing this in a little bit of a hacky way. But it will work. So we'll do a void set shooting true. Ideally, you want these to just run the same function, but I honestly don't care too much at the moment. So we'll make one for true and one for false, and we'll have a bool is shooting. And it's as simple as setting it false in this function, then copying over this function and making the true version of it. It is important to get the capitalization right though. And then adding those to these bindings. So we have the started will be the true, and then when we let go of it, it will be set to false. And then in our tick, it's as simple as if is shooting. We do this, and else we set it to the movement rotation. And that in theory should do the trick, I hope. And now we can walk around and we can shoot, and as long as we're shooting, we will be facing the direction that we're shooting. When we stop shooting, we use the wrong event. So I guess we need to use completed and not cancelled. I always get these events mixed up. They're really poorly named, in my opinion. I'm gonna just go ahead and say that. But now we can walk in any direction, and when we start shooting in a direction, there is one shot that still is fired in the direction that we were walking in. That's a little bit of a bug, but by and large, this is a more or less functioning twin-stick shooter now. Of course, at the moment, I don't have a controller to test this out with, but if you have a controller, this should work with 360-degree movement rather than just directional movement.
Окей. Окей. Это мы посмотрели все. Тут осталось чуть-чуть. 10 видео всего лишь. Но они такие по 10 минут. У него обычно по 10 минут нормально, хотя там он 2 видео по 22 минуты. Ну что ж. Ладно. В общем, неплохо. Неплохо. Я бы назвал из всех 8 видео, которые мы посмотрели, ну, может быть, видео 3-4 были прям то, что нужно. Остальные как-то пропустились. Вот. Что ж, ссылку на этого мужчину я оставлю в описании, на этот плейлист. Вот. Когда по C++ стрим. Ну, обычно я делаю через один. Обычно. Но это работает в течение недели. То есть понедельник это блюпринты, а потом... Короче, давай так, смотри. Первый плинт. Да, плинт. Не стрим, а плинт. Первый стрим это блюпринты на неделе. Следующий C++. Потом опять принты, потом опять плюс-плюс. И вот так вот чередуется. Вот. А там фиг его знает. То есть, по идее, должен быть в четверг. А там, если не получится завтра у меня по принтам, соответственно, значит в пятницу. И так далее. Вот. Ну, записи в любом случае будет. Что ж, неплохо. Неплохо получилось все. Неплохо. Вот так вот. Ладно. Всем спасибо, кто смотрел. Всем спасибо, кто слушал. И всем пока.